Enceladus stands as Saturn's sixth largest moon and one of the most promising candidates for harbouring life in our solar system. This icy world containing a global subsurface ocean beneath 15 to 20 kilometres of frozen water that has remained liquid for potentially billions of years. The Cassini spacecraft's decade-long exploration revealed Enceladus as a dynamic ocean world where liquid water exists in gravitational isolation from direct solar heating, maintained through tidal forces and internal geological activity that create conditions potentially suitable for complex biological evolution and even technological civilization development. Global ocean characteristics beneath Enceladus's ice shell demonstrate remarkable stability and depth. Ocean measurements indicating water depths reaching 26 to 31 kilometers while containing more liquid water than all Earth's oceans combined within a spherical shell surrounding the Moon's rocky core. This vast aquatic environment provides enormous three-dimensional habitat volume that could theoretically support substantial biological diversity and complex ecosystems. Ocean conditions remaining stable across geological timescales that exceed Earth's entire biological evolutionary history. Ice shell thickness varies across Enceladus's surface from less than 5 kilometers near the South Pole to over 30 kilometers in other regions. Ice thickness variations creating different environmental conditions and potential access routes between surface and subsurface environments. Thinner ice regions near the South Pole enable direct ocean surface interaction through crack systems and geysers that transport ocean materials to space, providing observational windows into subsurface ocean chemistry and potential biological processes. Gravitational isolation from solar radiation creates unique environmental conditions, where ocean temperatures and chemistry remain largely independent of solar variability. Subsurface ocean protection enabling long-term environmental stability that could support continuous biological evolution over billions of years. Radiation protection through ice shielding eliminates harmful cosmic radiation while maintaining chemical stability that enables complex organic molecule preservation and potential biological complexity development. Temperature profiles within Enceladus's ocean range from near freezing at the ice interface to potentially several degrees above freezing near the rocky core. Temperature gradients creating diverse thermal environments that could support different biological communities adapted to varying temperature conditions. Thermal diversity enables habitat specialization while providing environmental niches that could support biological diversity and ecosystem complexity throughout the ocean volume. Pressure conditions within the deep ocean create high-pressure environments similar to Earth's deep ocean trenches. Pressure conditions potentially enabling unique chemical processes and biological adaptations that differ from surface-based life while supporting pressure-adapted biological systems. High-pressure ocean conditions could enable specialized biochemistry and biological processes that utilize pressure gradients for energy production and biological function. Chemical stratification within the ocean potentially creates distinct chemical layers with different compositions and chemical conditions. Stratification enabling diverse chemical environments that could support different biological communities and ecosystem types throughout the ocean depth profile. Chemical diversity provides multiple environmental niches while enabling biological specialization that could support complex ecosystem development and biological diversity. Ocean circulation patterns driven by tidal heating and thermal gradients create dynamic water movement that distributes nutrients, chemicals, and potentially biological organisms throughout the ocean volume. Circulation enabling global ocean connectivity while supporting nutrient cycling and ecosystem integration. Dynamic circulation prevents stagnation while enabling global ocean biological connectivity that could support ecosystem development and biological evolution. Contact zones between ocean and rocky core create seafloor environments where water-rock interactions produce chemical energy sources and mineral resources that could support chemosynthetic biological communities. Seafloor contact enabling geological processes that generate chemical energy while providing solid substrates for biological attachment and ecosystem development. Seafloor interaction creates chemical energy while enabling diverse habitat types that could support biological complexity. Dissolved chemical composition includes salts, organic compounds, and dissolved gases that create chemical conditions potentially suitable for biological processes. Ocean chemistry providing essential elements and chemical energy sources while maintaining chemical conditions that could support biological metabolism and ecosystem development. Chemical composition enables biological processes while providing chemical resources that could support biological complexity and ecosystem function. Long-term ocean stability across geological timescales enables continuous biological evolution and ecosystem development that could potentially lead to intelligent life and technological civilization development. Ocean persistence providing sufficient time for complex biological evolution while maintaining environmental stability that supports continuous biological development. Temporal stability enables biological complexity while providing evolutionary timescales that could support intelligence development. Some believe Enceladus's ocean characteristics provide optimal conditions for biological evolution and potential civilization development based on ocean stability analysis and habitability assessment, while others suggest that subsurface ocean conditions may limit biological complexity despite favorable basic conditions for simple life development. The potential for complex life in Enceladus's ocean continues to be investigated as astrobiology understanding advances and future mission planning develops. Ocean chemistry analysis through plume observations reveals complex chemical compositions that include organic compounds and chemical energy sources that could support biological processes. Chemical analysis providing evidence for habitability while revealing chemical conditions that could enable biological development. Chemical complexity suggests biological potential while providing chemical foundations that could support ecosystem development. Future exploration missions could provide definitive evidence for biological activity through direct ocean sampling and biological detection techniques. Future missions potentially revealing biological signatures while providing direct evidence for life in Enceladus's subsurface ocean. Mission planning creates exploration opportunities while enabling biological detection that could confirm subsurface ocean life. The irony of Enceladus's hidden ocean lies in its potential for harboring advanced life while remaining completely invisible from external observation. Subsurface ocean potentially containing complex biological systems while appearing as lifeless icy moon from space-based observation. Ocean world demonstrating how biological complexity could develop in complete isolation from external detection while maintaining biological activity that remains hidden beneath planetary surfaces. Subsurface habitability, creating biological possibilities that transcend surface-based life detection, while potentially harboring biological systems that exceed surface-based biological complexity through environmental protection and stability that enables continuous biological evolution. Hydrothermal vent systems on Enceladus's ocean floor create chemical energy gradients through water-rock interactions that generate hydrogen gas, methane, and complex organic compounds, while providing energy sources that could support sophisticated biological communities through chemosynthesis rather than photosynthesis. Cassini spacecraft data revealed direct evidence for active seafloor hydrothermal activity through detection of silica particles and hydrogen gas in water vapor plumes, indicating ongoing geological processes that create chemical energy sources capable of supporting complex ecosystems and potentially advanced biological systems. Serpentinization reactions between ocean water and rocky core materials produce hydrogen gas through chemical processes that occur when water reacts with iron-rich rocks. Serpentinization creating continuous hydrogen production that provides chemical energy for biological metabolism, while generating alkaline conditions that support organic molecule formation. These geological processes operate independently of solar energy while creating chemical energy sources that could sustain complex biological communities across geological timescales. Chemical energy production through hydrothermal processes generates multiple energy sources including hydrogen oxidation, methane utilization, and sulfur compound metabolism that could support diverse biological communities with different metabolic strategies. Energy diversity enabling complex ecosystem development while providing chemical foundations for biological complexity that could support intelligent life evolution. Multiple energy sources create biological opportunities while enabling ecosystem diversity that transcends single-energy biological systems. Mineral precipitation at hydrothermal vents creates complex geological structures including chimneys, mineral deposits, and chemical gradients that provide habitat diversity and attachment surfaces for biological communities. Mineral formation creating three-dimensional habitat complexity while providing solid substrates that could support sessile biological communities and ecosystem development. Hydrothermal structures enable habitat diversity while creating biological attachment opportunities that support ecosystem complexity. Temperature gradients around hydrothermal vents create thermal diversity from high-temperature vent fluids to cold ambient ocean water. Temperature variation enabling thermal specialization and biological diversity that could support different biological communities adapted to specific temperature ranges. Thermal gradients provide environmental diversity while enabling biological specialization that could support ecosystem complexity and biological adaptation. Chemical gradients extending from hydrothermal vents create zones with different chemical compositions and energy availability that could support biological communities specialized for different chemical conditions. Chemical variation enabling metabolic diversity while providing chemical niches that could support biological specialization and ecosystem development. Chemical diversity creates biological opportunities while enabling biological adaptation to different chemical environments. Organic compound synthesis at hydrothermal vents produces complex organic molecules through chemical processes that combine carbon dioxide with hydrogen and other chemicals. Organic synthesis creating biological building blocks while providing chemical foundations for biological molecule formation and biological complexity development. Organic compound production enables biological chemistry while providing chemical precursors for biological system development. Continuous energy availability through ongoing hydrothermal activity provides persistent energy sources that could support long-term biological evolution and ecosystem development. Energy persistence enabling biological complexity while providing chemical energy that could sustain advanced biological systems across evolutionary timescales. Persistent energy sources create biological stability while enabling biological development that could support intelligence evolution. Circulation patterns around hydrothermal vents distribute chemical energy and nutrients throughout surrounding ocean regions, while creating chemical connectivity that enables biological dispersal and ecosystem integration. Circulation enabling biological connectivity while providing chemical transport that supports ecosystem development and biological evolution. Chemical circulation creates biological opportunities while enabling ecosystem integration that supports biological complexity. Microbial mat potential around hydrothermal vents could create complex biological communities similar to Earth's hydrothermal vent ecosystems. Biological community development enabling ecosystem complexity while providing biological foundations that could support food, web development, and biological diversity. Biological community formation creates ecosystem potential while enabling biological complexity that could support advanced biological systems. Symbiotic relationships between different biological organisms could develop around hydrothermal energy sources. Biological cooperation enabling biological complexity while creating biological partnerships that could support advanced biological capabilities and biological innovation. Symbiotic evolution creates biological cooperation while enabling biological advancement that could support intelligence development. Some believe hydrothermal vent systems provide sufficient energy for complex biological evolution, including potential intelligence development, based on energy availability analysis and biological complexity modeling. While others suggest that hydrothermal energy sources may support only simple biological systems, despite chemical energy abundance that could theoretically support biological complexity. The biological potential of hydrothermal energy continues to be investigated as astrobiology research advances and energy-life relationships are understood. Biogeochemical cycling around hydrothermal vents could create complex chemical cycling that supports ecosystem development and biological diversity. Chemical cycling enabling biological sustainability while providing chemical foundations that could support long-term biological evolution and ecosystem stability. Chemical cycling creates biological sustainability while enabling biological development that could support advanced biological systems. Evolutionary potential in hydrothermal environments could enable biological innovation and biological complexity development through chemical energy utilization and environmental adaptation. Evolutionary development enabling biological advancement while providing biological mechanisms that could support intelligence evolution and technological development. Evolutionary processes create biological potential while enabling biological complexity that could support advanced biological capabilities. The irony of hydrothermal vent energy lies in its creation of biological opportunities through geological processes that operate independently of biological activity. Geological energy creating biological potential while providing chemical foundations for biological complexity that transcends geological processes. Hydrothermal activity enabling biological development through chemical energy production that supports biological systems, while demonstrating how geological processes can create biological opportunities through chemical energy generation that enables biological complexity development. Geological-biological interaction creating biological potential through chemical energy production that could support advanced biological systems, including potential technological civilizations that utilize hydrothermal energy for biological and technological development. Tidal heating generates internal thermal energy through Saturn's gravitational forces that rhythmically flex Enceladus's interior structure, creating frictional heating that maintains liquid oceans and drives active geological processes essential for long-term habitability and potential civilization development. This gravitational energy source operates continuously across geological timescales while providing reliable heating that prevents ocean freezing and maintains dynamic internal processes that could support complex biological evolution through persistent energy input that transcends solar heating limitations. Orbital resonance patterns between Enceladus and other Saturnian moons create gravitational interactions that amplify tidal heating effects through resonant orbital relationships. Orbital mechanics generating enhanced tidal forces that increase internal heating while maintaining orbital stability that ensures continuous tidal energy production. Resonant orbital relationships create gravitational amplification while providing stable orbital configurations that sustain tidal heating across astronomical timescales. Internal structure flexing through tidal forces creates mechanical deformation within Enceladus's interior that generates heat through friction between internal materials. Structural flexing producing thermal energy while creating internal circulation that distributes heat throughout the moon's interior and maintains liquid ocean conditions. Mechanical deformation enables thermal generation while creating internal dynamics that support geological activity and ocean maintenance. Geological activity driven by tidal heating creates seafloor volcanism, tectonic processes, and hydrothermal circulation that provide chemical energy sources and habitat diversity essential for biological evolution. Geological processes enabling chemical energy generation while creating environmental complexity that could support diverse biological communities and ecosystem development. Active geology creates biological opportunities while providing chemical foundations for biological complexity. Heat distribution throughout Enceladus's interior creates temperature gradients that maintain liquid ocean conditions while preventing complete freezing that would eliminate biological habitat. Thermal distribution enabling ocean persistence while providing temperature variation that could support diverse biological communities adapted to different thermal conditions. Heat distribution maintains habitability while creating thermal diversity that supports biological adaptation. Thermal evolution modeling suggests tidal heating has maintained liquid oceans throughout Enceladus's history. Thermal modeling indicating continuous ocean conditions while providing evidence for long-term habitability that could enable complex biological evolution and potential intelligence development. Thermal persistence creates biological opportunity while providing environmental stability that supports continuous biological development. Crack formation and surface renewal through tidal stress create dynamic surface processes that enable ocean surface interaction and material exchange between subsurface ocean and space environment. Surface dynamics enabling chemical exchange while providing potential communication pathways between subsurface environments and external observation. Surface activity creates connectivity while enabling chemical signatures that could indicate subsurface biological activity. Internal circulation patterns driven by tidal heating create ocean currents and convection that distribute nutrients, chemicals, and potentially biological organisms throughout ocean volume. Circulation enabling biological connectivity while providing transport mechanisms that support ecosystem integration and biological dispersal. Internal circulation creates biological distribution while enabling ecosystem connectivity that supports biological complexity. Pressure cycling through tidal forces creates variable pressure conditions that could drive chemical processes and biological adaptations. Pressure variation enabling chemical reactions while providing environmental variation that could support biological diversity and biological innovation. Pressure cycling creates chemical opportunities while enabling biological adaptation that could support biological complexity. Energy budget calculations for tidal heating reveal substantial energy availability that exceeds biological energy requirements by orders of magnitude. Energy abundance providing more than sufficient power for complex biological systems while enabling energy utilization that could support technological development and advanced biological capabilities. Energy abundance creates biological potential while providing energy foundations that could support civilization development. Long-term tidal heating sustainability ensures continuous energy availability across geological and evolutionary timescales. Energy persistence enabling biological evolution while providing energy security that could support long-term biological development and potential civilization sustainability. Energy sustainability creates biological security while enabling biological development that transcends short-term energy availability. Some believe tidal heating provides optimal energy sources for supporting complex life and potential civilization development based on energy availability analysis and geological activity assessment, while others suggest that tidal energy may create environmental instability despite energy abundance that could theoretically support biological complexity. The role of tidal heating in biological evolution continues to be investigated as planetary science advances and astrobiology understanding develops. Comparative analysis with other tidally heated moons reveals that tidal heating represents common energy source throughout outer solar system. Comparative studies indicating widespread tidal heating while suggesting multiple ocean worlds that could harbor biological systems supported by tidal energy. Comparative analysis reveals tidal heating universality while indicating multiple potential habitats throughout outer solar system. Future mission planning incorporates tidal heating understanding for targeting optimal exploration locations and biological detection strategies. Mission planning utilizing tidal heating knowledge, while designing exploration approaches that could detect biological signatures associated with tidal energy utilization. Mission design creates exploration opportunities while enabling biological detection in tidally heated environments. The irony of tidal heating lies in its utilization of gravitational forces for biological energy production. Gravitational interaction creating biological opportunities while providing energy sources that enable biological complexity through astronomical mechanics that operate independently of biological systems. Tidal energy creating biological potential through gravitational processes that transcend biological control while enabling biological development that could utilize astronomical energy for biological advancement. Astronomical biological interaction creating biological opportunities through gravitational energy that supports biological systems while demonstrating how astronomical processes can enable biological complexity through energy production that supports biological evolution and potential technological civilization development. Water vapor plumes erupting from Enceladus's south polar regions provide direct observational access to subsurface ocean chemistry through material ejection that transports ocean water, dissolved chemicals, and organic compounds into space where spacecraft can analyze composition and detect potential biological signatures. Cassini spacecraft analysis of plume materials revealed complex chemistry including salts, organic molecules, silica particles, and molecular hydrogen that indicate active ocean-seafloor interactions and chemical conditions potentially suitable for biological processes and ecosystem development. Organic compound detection in plume materials demonstrates presence of carbon-based molecules including methane, carbon dioxide, and complex organic compounds that provide chemical building blocks essential for biological systems. Organic chemistry indicating chemical foundations for biological processes, while revealing chemical complexity that could support biological molecule formation and biological system development. Organic compound presence creates biological potential while providing chemical evidence for biological habitability. Salt concentration analysis reveals ocean salinity levels similar to Earth's oceans through sodium chloride and other dissolved salts that indicate substantial water-rock interaction and chemical evolution. Salt composition providing evidence for mature ocean chemistry while indicating chemical conditions that could support biological processes similar to terrestrial marine environments. Salt composition indicates ocean maturity while providing chemical foundations for biological systems. Silica particle detection indicates ongoing hydrothermal activity through mineral formation that requires high-temperature water-rock interactions at ocean floor depths. Silica presence providing direct evidence for active geological processes while indicating energy sources and chemical conditions that could support chemosynthetic biological communities. Silica detection confirms hydrothermal activity while indicating geological energy sources that could support biological systems. Molecular hydrogen abundance in plume materials indicates serpentinization reactions occurring at the ocean floor through water-rock interactions that produce hydrogen gas essential for chemosynthetic metabolism. Hydrogen detection providing evidence for chemical energy sources while indicating metabolic opportunities that could support biological communities independent of solar energy. Hydrogen abundance indicates energy availability while providing chemical foundations for biological energy production. Temperature measurements of plume materials reveal thermal conditions consistent with liquid water and active geological processes. Temperature data indicating suitable thermal conditions for biological processes while revealing thermal energy that could support biological activity and ecosystem development. Temperature conditions indicate biological suitability while providing thermal foundations for biological systems. Isotopic ratios in plume materials provide information about chemical processes and potential biological activity through isotopic fractionation that could indicate biological metabolism or geological processes. Isotopic analysis revealing chemical signatures while providing potential biological indicators that could distinguish between geological and biological chemical processes. Isotopic analysis provides chemical diagnostics while enabling biological detection through chemical signatures. Particle size distribution in plumes indicates diverse material sources from fine aerosols to larger particles that suggest complex ocean processes and material transport mechanisms. Particle analysis revealing ocean dynamics while providing information about material sources and transport processes that could affect biological distribution and ecosystem connectivity. Particle analysis indicates ocean complexity while revealing material transport that could support biological systems. Chemical variability in plume composition over time suggests dynamic ocean processes and chemical evolution that indicate active systems capable of supporting changing environmental conditions. Chemical variation indicating ocean dynamics while revealing environmental changes that could support biological adaptation and ecosystem evolution. Chemical dynamics indicate ocean activity while providing environmental variation that could support biological complexity. Plume eruption patterns reveal correlation with orbital position and tidal stress that indicates geological control over ocean access. Eruption timing providing information about geological processes while revealing ocean surface connectivity that could enable material exchange and potential biological dispersal. Eruption patterns indicate geological activity while revealing connectivity that could support biological processes. Future plume analysis missions could provide enhanced chemical detection and potential biological signature identification through improved analytical techniques and direct plume sampling. Future missions enabling biological detection while providing chemical analysis that could reveal biological activity and ecosystem characteristics. Future analysis creates detection opportunities while enabling biological investigation through chemical analysis. Some believe plume chemistry provides compelling evidence for biological habitability and potential biological activity based on chemical composition analysis and organic compound detection, while others suggest that plume chemistry indicates geological processes despite chemical complexity that could theoretically support biological systems. The interpretation of plume chemistry for biological significance continues to be investigated as analytical techniques advance and chemical understanding develops. Amino acid detection potential in future plume sampling could provide direct evidence for biological activity through biological molecule identification. Amino acid analysis enabling biological detection, while providing chemical evidence for biological processes that could indicate biological activity and ecosystem development. Amino acid detection creates biological evidence while enabling biological confirmation through chemical analysis. Chemical evolution modeling based on plume composition reveals potential pathways for biological molecule formation and biological system development. Chemical modeling indicating biological potential while revealing chemical processes that could support biological complexity and ecosystem development. Chemical modeling creates biological understanding while enabling biological potential assessment through chemical analysis. The irony of plume chemical accessibility lies in its provision of direct ocean chemistry analysis through geological processes that enable external observation of internal ocean conditions, geological activity creating observational opportunities while providing chemical access to subsurface environments that remain otherwise inaccessible. Plume ejection enabling chemical investigation while revealing ocean chemistry that could indicate biological activity. Geological processes creating biological detection opportunities through material ejection that enables chemical analysis of subsurface biological potential, while demonstrating how geological activity can provide observational access to hidden biological systems through chemical signatures that indicate biological possibilities. Chemical composition analysis reveals dissolved salts, carbon compounds, and molecular hydrogen that create conditions potentially suitable for life as we understand it. Ocean chemistry providing essential chemical elements and energy sources, while maintaining chemical equilibria that could support biological metabolism and complex biochemical processes. Enceladus's ocean chemistry demonstrates remarkable similarity to Earth's early ocean conditions, while containing chemical diversity that could support multiple metabolic pathways and biological adaptation strategies through chemical environment optimization for biological system development. Dissolved salt concentrations indicate mature ocean chemistry through extensive water-rock interactions that have enriched ocean water with essential minerals including sodium, chloride, potassium, and other ions necessary for biological processes. Salt chemistry providing chemical foundations for biological systems while creating ionic environments that could support cellular function and biological membrane stability. Salt composition indicates chemical evolution while providing chemical conditions that support biological viability. Carbon compound diversity includes dissolved carbon dioxide, methane, and complex organic molecules that provide carbon sources essential for biological molecule synthesis and biological system construction. Carbon chemistry enabling biological molecule formation while providing chemical building blocks that could support biological complexity and ecosystem development. Carbon availability creates biological potential while providing chemical foundations for biological system development. Molecular hydrogen abundance provides chemical energy sources through hydrogen oxidation reactions that could support chemosynthetic metabolism, independent of solar energy. Hydrogen availability, enabling chemical energy production while providing metabolic opportunities that could support biological communities and ecosystem development. Hydrogen energy creates biological opportunities while providing chemical power sources for biological systems. pH conditions within Enceladus's ocean indicate alkaline chemistry that favors organic molecule stability and biological process optimization. pH levels, providing chemical conditions that support biological molecule preservation while creating chemical environments that enable biological process efficiency and biological system stability. pH optimization creates biological suitability while providing chemical conditions that support biological function. Dissolved oxygen potential through water radiolysis could provide oxygen sources for aerobic metabolism while creating chemical diversity that enables multiple metabolic strategies. Oxygen availability, enabling aerobic biological processes while providing chemical options that could support biological diversity and ecosystem complexity. Oxygen potential creates metabolic opportunities while enabling biological diversity through chemical variation. Trace element chemistry includes dissolved metals and minerals essential for biological enzyme function and biological process catalysis. Trace element availability providing chemical cofactors while enabling biological process optimization that could support complex biological systems and biological innovation. Trace element diversity creates biological functionality while providing chemical tools for biological system optimization. Chemical energy gradients between different ocean regions create chemical potential that could drive biological processes and biological organization. Chemical gradients enabling energy utilization while providing chemical driving forces that could support biological complexity and biological system development. Chemical gradients create energy opportunities while enabling biological organization through chemical potential utilization. Redox chemistry potential through chemical reactions between different dissolved compounds could create chemical energy sources and chemical environments that support diverse biological metabolisms. Redox reactions enabling chemical energy production while providing chemical variety that could support biological diversity and ecosystem development. Redox chemistry creates energy diversity while enabling biological metabolic variety through chemical reaction utilization. Chemical stability over geological timescales indicates persistent chemical conditions that could support long-term biological evolution and biological system development. Chemical persistence enabling biological continuity while providing chemical reliability that supports biological adaptation and biological complexity development. Chemical stability creates biological security while enabling biological development through chemical environmental persistence. Nutrient availability through dissolved chemical compounds provides essential nutrients for biological growth and biological system maintenance. Nutrient chemistry enabling biological productivity while providing chemical resources that could support biological communities and ecosystem sustainability. Nutrient availability creates biological productivity while enabling biological system support through chemical resource provision. Some believe ocean chemistry provides optimal conditions for biological evolution and potential intelligence development based on chemical composition analysis and biological habitability assessment, while others suggest that ocean chemistry may support only simple biological systems despite chemical complexity that could theoretically enable biological advancement. The biological potential of ocean chemistry continues to be investigated as astrobiology research advances and chemical biological relationships are understood. Chemical complexity indicates sophisticated chemical processes and chemical evolution that could support biological innovation and biological system complexity. Chemical sophistication enabling biological advancement while providing chemical foundations that could support technological biological systems and biological civilization development. Chemical complexity creates biological potential while enabling biological innovation through chemical utilization. Comparative chemistry analysis with Earth's ocean chemistry reveals remarkable similarities and important differences that provide insights into biological potential and biological habitat suitability. Comparative analysis indicating biological compatibility, while revealing chemical conditions that could support biological systems similar to terrestrial biological communities. Comparative chemistry provides biological context while enabling biological potential assessment through chemical comparison. The irony of chemical habitability lies in its creation of biological potential through non-biological chemical processes that establish chemical conditions suitable for biological systems. Chemical evolution creating biological opportunities while providing chemical foundations for biological development that transcend chemical processes. Ocean chemistry enabling biological possibility through chemical evolution that operates independently of biological systems while creating chemical conditions that could support biological complexity. Chemical biological compatibility, demonstrating how chemical processes can create biological potential through chemical environment optimization that enables biological system development and biological innovation through chemical resource provision that supports biological advancement. Subsurface ocean depth measurements reveal water depths reaching 31 kilometers beneath Enceladus's ice shell, creating an aquatic environment that contains more liquid water than all Earth's oceans, combined within a spherical shell that provides three-dimensional habitat volume exceeding terrestrial marine environments. This vast subsurface ocean offers enormous spatial resources for biological evolution and ecosystem development, while providing habitat diversity that could support complex biological communities and potentially advanced civilizations adapted to three-dimensional aquatic environments. Volume calculations demonstrate that Enceladus's ocean contains approximately 10 times the water volume of Earth's oceans, despite the Moon's much smaller size. Water abundance providing extensive habitat space while creating aquatic environments that could support substantial biological populations and complex ecosystem structures. Ocean volume abundance enables biological community development while providing spatial resources that could support biological diversity and ecosystem complexity beyond terrestrial limitations. Three-dimensional habitat utilization in spherical ocean environments creates habitat opportunities that transcend surface-based biological systems. Aquatic three-dimensional space, enabling biological colonization throughout ocean depth while providing habitat diversity that could support biological specialization and ecosystem stratification. Three-dimensional habitat creates biological opportunities while enabling biological distribution that utilizes complete ocean volume for biological system development. Pressure stratification throughout ocean depth creates varying pressure environments from surface pressure at ice interface to high pressure near rocky core. Pressure variation enabling biological adaptation while providing pressure-based habitat diversity that could support biological communities specialized for different pressure conditions. Pressure stratification creates biological niches while enabling biological specialization that could support ecosystem complexity through pressure adaptation. Temperature stratification throughout ocean depth creates thermal layers with different temperature conditions that could support biological communities adapted to specific thermal environments. Temperature variation enabling thermal specialization while providing thermal habitat diversity that supports biological adaptation and ecosystem development. Temperature stratification creates thermal opportunities while enabling biological adaptation that supports ecosystem diversity through thermal specialization. Chemical stratification throughout ocean depth could create chemical layers with different compositions and chemical conditions that support biological communities specialized for different chemical environments. Chemical variation enabling metabolic specialization while providing chemical habitat diversity that supports biological adaptation and ecosystem complexity. Chemical stratification creates chemical opportunities while enabling biological specialization that supports ecosystem development through chemical adaptation. Circulation patterns throughout ocean volume create water movement that distributes nutrients, chemicals, and biological organisms throughout three-dimensional ocean space. circulation enabling biological connectivity while providing transport mechanisms that support ecosystem integration and biological dispersal throughout ocean habitat. Ocean circulation creates biological connectivity while enabling ecosystem integration that supports biological community development. Habitat zones throughout ocean depth could include surface zones, midwater zones, and benthic zones that provide different environmental conditions and biological opportunities similar to terrestrial ocean zonation. Habitat zonation enabling ecological specialization while providing biological niches that could support diverse biological communities and ecosystem complexity. Habitat zonation creates ecological opportunities while enabling biological specialization that supports ecosystem diversity. Biomass potential calculations suggest ocean volume could theoretically support substantial biological populations that exceed terrestrial marine biomass through efficient, three-dimensional space utilization. Biomass potential enabling biological abundance while providing biological foundations that could support complex food webs and ecosystem productivity. Biomass potential creates biological abundance while enabling biological community development that could support ecosystem complexity. Resource distribution throughout ocean volume provides chemical and energy resources that could support biological communities throughout three-dimensional ocean space. Resource availability enabling biological productivity while providing chemical foundations that support biological system development and ecosystem sustainability. Resource distribution creates biological opportunity while enabling biological productivity that supports ecosystem development throughout ocean volume. Radiation protection through ice shell shielding eliminates harmful cosmic radiation throughout ocean volume, while creating a radiation-free environment that enables biological development without radiation damage. Radiation protection enabling biological survival while providing biological security that supports biological evolution and biological complexity development. Radiation protection creates biological safety while enabling biological development that transcends radiation limitations. Some believe ocean depth and volume provide optimal habitat conditions for complex biological evolution, including potential intelligence development based on habitat analysis and biological potential assessment, while others suggest that deep ocean conditions may limit biological complexity despite habitat abundance that could theoretically support biological advancement. The biological potential of deep ocean habitat continues to be investigated as astrobiology research advances and habitat biology relationships are understood. Seafloor habitat near rocky core provides solid, substrate environments that could support sessile biological communities and geological interaction. Seafloor habitat enabling biological attachment while providing chemical resources that support biological communities through water-rock chemical interactions. Seafloor environments create biological opportunity while enabling biological communities that utilize solid substrate habitat. Free-floating habitat throughout water column provides three-dimensional biological opportunities that enable biological communities adapted to suspended aquatic living. Free-floating habitat enabling biological adaptation while providing biological opportunities that utilize complete water column space for biological system development. Free-floating habitat creates biological diversity while enabling biological communities that transcend substrate-based limitations. The irony of vast hidden oceans lies in their provision of enormous biological habitat that remains completely invisible from external observation. Subsurface ocean volume creating extensive biological potential while remaining hidden beneath planetary surfaces that appear lifeless from space-based observation. Ocean habitat abundance enabling biological complexity while demonstrating how biological opportunity can exist in complete isolation from external detection. Vast aquatic habitat creating biological possibilities that transcend surface-based biological assumptions while providing biological resources that could support advanced biological systems, including potential technological civilizations that remain hidden within planetary ocean environments. Titan presents alternative habitability scenarios through hydrocarbon lakes and rivers that contain liquid methane and ethane at surface temperatures around -179 degrees Celsius. creating exotic chemical environments where alternative biochemistry could potentially operate using hydrocarbons as solvents rather than water-based biological systems. These hydrocarbon environments represent fundamentally different chemical conditions that could support biological processes adapted to low temperatures and hydrocarbon chemistry, demonstrating how life might evolve under radically different chemical conditions that transcend water-based biological assumptions. Methane cycle dynamics on Titan create weather systems and seasonal variations that transport methane through atmosphere, surface, and subsurface environments while creating chemical cycles that could support biological processes adapted to hydrocarbon chemistry. Methane cycling enables chemical transport while providing chemical variation that could support biological adaptation and biological system development through hydrocarbon-based chemistry that operates under completely different chemical principles than terrestrial biological systems. Kraken Mare and other hydrocarbon seas provide vast liquid environments that contain complex hydrocarbon mixtures including methane, ethane, and dissolved organic compounds that could serve as chemical foundations for alternative biological systems. Hydrocarbon seas enabling chemical diversity while providing liquid environments that could support biological processes adapted to hydrocarbon solvents. Hydrocarbon seas create chemical opportunities while enabling biological possibilities through alternative chemical environments. Atmospheric chemistry complexity includes nitrogen, methane, hydrogen, and complex organic compounds that create chemical conditions potentially suitable for alternative biochemistry operating through gas phase reactions and atmospheric chemical processes. Atmospheric complexity enabling chemical interactions while providing chemical foundations that could support biological systems adapted to atmospheric chemical environments. Atmospheric chemistry creates chemical diversity while enabling biological potential through atmospheric chemical utilization. Surface organic chemistry demonstrates presence of complex hydrocarbon compounds, including tholins and other organic polymers that could provide chemical building blocks for alternative biological systems. Organic chemistry enabling biological molecule formation while providing chemical foundations that could support biological complexity through hydrocarbon-based biological molecules. Organic chemistry creates biological potential while enabling biological system development through alternative chemical pathways. Subsurface water ocean beneath Titan's surface provides additional habitat potential through liquid water environment that could support conventional biological systems while creating dual habitability through both hydrocarbon surface environments and water subsurface environments. Dual habitability enables biological diversity while providing multiple environmental options that could support different biological systems adapted to different chemical conditions. Temperature conditions on Titan's surface create low-temperature environments that require biological adaptations different from terrestrial biological systems. Temperature adaptation enabling biological survival while requiring biological innovations that could support biological systems under extreme cold conditions. Temperature adaptation creates biological challenges while enabling biological innovation through temperature adaptation strategies. Energy sources for alternative biochemistry could include chemical gradients, atmospheric chemical reactions, and hydrocarbon metabolism that provide energy for biological processes operating through alternative chemical pathways. Energy availability enabling biological metabolism while providing chemical power sources that could support biological systems through hydrocarbon-based energy production. Energy sources create biological opportunities while enabling biological metabolism through alternative chemical energy utilization. Prebiotic chemistry potential in hydrocarbon environments could enable organic molecule formation and biological molecule synthesis through chemical processes that operate under Titan's environmental conditions. Prebiotic chemistry enabling biological molecule formation while providing chemical pathways that could support biological system development through alternative chemical synthesis. Prebiotic chemistry creates biological foundations while enabling biological molecule formation through alternative chemical processes. Seasonal variations in hydrocarbon distribution create environmental changes that could support biological adaptation and biological diversity through environmental variation that enables biological specialization and biological system development. Seasonal variation enabling biological adaptation while providing environmental diversity that supports biological complexity through environmental change adaptation. Seasonal variation creates biological opportunities while enabling biological adaptation through environmental variation. Communication potential between surface and subsurface environments could enable biological exchange and biological connectivity between different habitat types. Communication enabling biological integration while providing biological opportunities that utilize multiple environmental conditions for biological system development. Environmental connectivity creates biological opportunities while enabling biological diversity through multi-environment biological systems. Some believe Titan's hydrocarbon environments provide viable alternative habitability scenarios based on chemical analysis and alternative biochemistry research, while others suggest that hydrocarbon environments may not support complex biological systems despite chemical complexity that could theoretically enable alternative biological processes. The viability of hydrocarbon-based biological systems continues to be investigated as astrobiology research advances and alternative biochemistry understanding develops. Dragonfly mission prospects for Titan exploration could provide direct evidence for alternative biological systems through surface analysis and chemical detection that could reveal biological signatures in hydrocarbon environments. Future exploration enabling biological detection while providing investigation opportunities that could confirm alternative biological systems. Future exploration creates detection opportunities while enabling biological investigation through alternative environment analysis. Laboratory simulation studies of Titan conditions provide insights into alternative biochemistry potential and biological system viability under hydrocarbon environmental conditions. Laboratory research enabling alternative biochemistry investigation while providing experimental evidence for biological potential under Titan-like conditions. Laboratory research creates understanding while enabling alternative biochemistry investigation through experimental simulation. The irony of Titan's alternative habitability lies in its demonstration of biological potential through completely different chemical systems that challenge conventional biological assumptions. Hydrocarbon environments creating biological possibilities while operating through chemical systems that differ fundamentally from water-based biological assumptions. Alternative habitability revealing biological potential while demonstrating how biological systems could operate through radically different chemical foundations. Titan environments creating biological opportunities while showing how biological potential transcends water-based biological limitations through alternative chemical systems that could support biological complexity through completely different biochemical pathways that enable biological innovation. Ancient ocean stability modeling suggests Enceladus's subsurface ocean has remained liquid for approximately 4.5 billion years through continuous tidal heating that has maintained thermal conditions necessary for ocean persistence throughout the Moon's entire geological history. This extraordinary temporal stability provides sufficient time for complex biological evolution, including development of intelligent life and potential technological civilizations. Ocean longevity enabling evolutionary processes that could support biological complexity development across geological timescales that exceed Earth's entire biological evolutionary history. Thermal evolution calculations demonstrate that tidal heating has consistently provided energy input sufficient to prevent ocean freezing throughout Enceladus's history. Thermal modeling indicating continuous ocean conditions while revealing energy balance that maintains liquid water despite cold external temperatures. Thermal persistence enables biological continuity while providing thermal stability that supports long-term biological evolution and biological system development across astronomical timescales. Orbital dynamic stability ensures continued tidal heating through orbital resonance relationships that maintain gravitational interactions necessary for tidal energy generation. Orbital stability providing energy security while ensuring continued tidal heating that maintains ocean conditions across geological time. Orbital stability creates energy reliability while enabling continuous tidal heating that supports ocean persistence and biological habitat maintenance. Geological evidence from surface features suggests long-term geological activity that indicates persistent internal heating and ocean activity throughout Enceladus's history. Geological indicators providing evidence for temporal stability while revealing continuous geological processes that support ocean maintenance and biological habitat persistence. Geological evidence confirms temporal stability while indicating continuous activity that supports biological habitat. Chemical evolution over billions of years enables sophisticated chemical development that could support biological complexity and biological innovation through chemical evolution that operates across geological timescales. Chemical development enabling biological advancement while providing chemical foundations that could support biological complexity, development through extended chemical evolution. Chemical evolution creates biological potential while enabling biological advancement through chemical development. Biological evolution timescales indicate that 5 billion years provides more than sufficient time for evolution of complex biological systems, including nervous systems, intelligence, and potential technological development. Evolutionary timescales enabling biological complexity while providing temporal foundations that could support intelligence evolution and civilization development. Evolutionary time enables biological advancement while providing temporal resources for biological complexity development. Ecosystem development potential across billions of years enables sophisticated ecosystem evolution that could support complex food webs, biological interactions, and ecosystem complexity that transcends simple biological systems. Ecosystem evolution enabling biological complexity while providing biological foundations that could support advanced biological communities and biological civilization development. Ecosystem development creates biological complexity while enabling biological advancement through ecosystem evolution. Environmental stability maintenance through continuous ocean conditions provides reliable environmental foundations that enable consistent biological evolution without environmental disruption. Environmental stability enabling biological continuity while providing biological security that supports biological development and biological innovation across geological timescales. Environmental stability creates biological reliability while enabling biological development through environmental consistency. Comparative evolution analysis with Earth's biological evolution reveals that 5 billion years exceeds Earth's biological evolutionary timescale while providing equivalent or greater time for biological complexity development. Comparative analysis, indicating sufficient evolutionary time while revealing temporal adequacy for biological advancement, including intelligence development. Comparative evolution provides temporal context while enabling biological potential assessment through evolutionary time comparison. Intelligence evolution potential across billions of years enables nervous system development, cognitive evolution, and potential technological development that could support civilization development through extended evolutionary processes. Intelligence evolution enabling cognitive advancement while providing biological foundations that could support technological civilization development through extended biological evolution. Intelligence evolution creates cognitive potential while enabling technological development through biological advancement. Technological development potential through billions of years of biological evolution could enable sophisticated technological systems adapted to aquatic environments and subsurface conditions. Technological evolution enabling technological advancement while providing technological foundations that could support advanced civilization development through biological-technological co-evolution. Technological potential creates civilization opportunity while enabling technological advancement through biological-technological development. Some believe ancient ocean stability provides optimal conditions for complex biological evolution, including potential civilization development based on temporal analysis and evolutionary potential assessment, while others suggest that Ocean stability may not guarantee biological complexity despite temporal adequacy for biological evolution that could theoretically support biological advancement. The relationship between temporal stability and biological complexity continues to be investigated as evolutionary biology advances and astrobiology understanding develops. Civilization sustainability potential through continuous ocean conditions enables long-term civilization development that could support technological advancement and civilization complexity that transcends short-term environmental limitations. Civilization sustainability enabling cultural development while providing environmental foundations that support civilization persistence and civilization advancement. Civilization sustainability creates cultural opportunity while enabling civilization development through environmental stability. Cultural evolution potential across billions of years enables sophisticated cultural development that could support complex societies, technological innovation, and civilization advancement that transcends simple technological development. Cultural evolution enabling social complexity while providing cultural foundations that could support advanced civilization development through extended cultural evolution. Cultural evolution creates social potential while enabling civilization advancement through cultural development. The irony of ancient ocean stability lies in its provision of unprecedented biological evolutionary opportunity through environmental persistence that enables biological complexity development while remaining completely isolated from external observation. Temporal stability, creating biological potential while providing evolutionary foundations that could support biological advancement that transcends surface-based biological evolution. Ocean persistence enabling biological opportunity while demonstrating how environmental stability can create biological complexity through extended evolutionary processes that support biological advancement, including potential technological civilization development that operates in complete isolation from external detection through environmental persistence that enables biological evolution. Communication challenges through ice barriers represent formidable obstacles for any subsurface civilization attempting to establish contact with surface environments or external space. Kilometers of solid ice creating physical barriers that prevent electromagnetic signal transmission while requiring extraordinary technological solutions for communication across ice shell thickness. Advanced subsurface civilizations would face unprecedented engineering challenges in developing communication technologies capable of penetrating dense ice barriers while maintaining signal integrity across geological barriers that exceed terrestrial communication obstacles. Electromagnetic signal attenuation through ice absorption creates severe communication limitations where radio waves, microwaves, and other electromagnetic signals experience dramatic signal loss through ice propagation. Signal attenuation preventing conventional communication while requiring alternative communication strategies that transcend electromagnetic limitations. Ice absorption eliminates conventional communication while creating technological challenges that require innovative communication solutions for ice barrier penetration. Ice shell drilling requirements for physical communication pathways would demand enormous technological capabilities to excavate tunnels or shafts through 30 kilometers of solid ice, while maintaining structural stability and preventing ice reformation. Drilling technology requiring unprecedented engineering, while creating physical access that enables communication pathway establishment. Drilling communication represents massive technological undertaking while enabling physical communication through ice barrier penetration. Acoustic communication potential through ice transmission could enable sound wave communication across ice barriers through seismic wave propagation and acoustic signal transmission. Acoustic communication providing alternative communication while enabling signal transmission that utilizes mechanical wave propagation through solid ice. Acoustic signals create communication opportunity while enabling mechanical signal transmission through ice barrier communication. Chemical communication strategies could utilize chemical signal release and chemical message transmission through crack systems and geological pathways that enable chemical information transport across ice barriers. Chemical communication enabling information transmission while providing communication strategies that utilize chemical signal propagation through geological communication pathways. Chemical signals create communication alternatives while enabling information transmission through chemical communication methods. Thermal communication through heat signature generation could create thermal signals that penetrate ice barriers and create detectable thermal signatures at surface levels. Thermal communication enabling signal transmission while providing communication strategies that utilize thermal signal propagation through isothermal communication. Thermal signals create detection opportunity while enabling thermal signature communication through ice barrier thermal transmission. Biological communication through biological signal generation could utilize biological processes to create chemical or biological signatures that indicate subsurface biological activity. Biological communication enabling biological signal transmission while providing communication strategies that utilize biological processes for signal generation and biological information transmission. Biological signals create biological communication while enabling biological information transmission through biological signal utilization. Geological modification for communication could involve large-scale geological engineering that creates geological features detectable from surface observation. Geological communication enabling signal transmission while providing communication strategies that utilize geological modification for information transmission and geological signal creation. Geological engineering creates communication opportunity while enabling geological signal transmission through geological modification. Plume utilization for communication could involve manipulation of natural plume systems to encode information within plume materials and plume ejection patterns. Plume communication enabling information transmission while providing communication strategies that utilize natural geological processes for information encoding and signal transmission. Plume manipulation creates communication opportunity while enabling information transmission through plume signal encoding. Long-term communication strategies could involve multi-generational communication projects that operate across extended timescales to overcome ice barrier communication challenges through persistent communication efforts. Long-term communication enabling signal transmission while providing communication strategies that utilize extended temporal approaches for communication barrier resolution. Long-term approaches create communication persistence while enabling communication through extended temporal communication strategies. Surface signal detection challenges require extremely sensitive detection equipment and sophisticated signal analysis to identify subsurface communication attempts through ice barrier signal transmission. Detection challenges requiring technological advancement while demanding signal analysis capability that exceeds conventional detection limitations. Detection challenges create technological requirements while demanding signal analysis advancement for subsurface communication detection. Some believe subsurface civilizations could develop communication technologies capable of ice barrier penetration based on technological advancement potential and communication innovation analysis, while others suggest that ice barriers may prevent communication despite technological development that could theoretically enable communication breakthrough solutions. The viability of ice barrier communication continues to be investigated as communication technology advances and barrier penetration research develops. Quantum communication potential through quantum signal transmission could enable quantum information transfer that transcends conventional electromagnetic limitations through quantum communication technologies. Quantum communication enabling information transmission while providing communication strategies that utilize quantum signal transmission for barrier penetration communication. Quantum signals create communication innovation while enabling quantum information transmission through quantum communication advancement. Collaborative communication efforts between surface and subsurface civilizations could enable communication establishment through coordinated communication attempts that utilize multiple communication strategies and communication technologies. Collaborative communication enabling signal establishment while providing communication coordination that supports communication breakthrough through collaborative communication development. Collaborative approaches create communication opportunity while enabling communication establishment through coordinated communication efforts. The irony of ice barrier communication lies in its creation of complete communication isolation for potentially advanced civilizations while providing perfect environmental protection that enables civilization development and complete secrecy. Ice barriers preventing communication while creating civilization protection that enables biological and technological development without external interference. Communication isolation creating technological challenges while providing environmental security that supports civilization advancement. Ice barrier isolation demonstrating how environmental protection can create communication limitations while enabling civilization development that operates in complete isolation from external detection through environmental barriers that prevent communication while supporting civilization advancement. Energy sources for complex life within Enceladus's subsurface environment include hydrothermal vents, radiolysis, and tidal heating that provide multiple independent energy pathways capable of supporting sophisticated biological systems and potentially technological development through chemical energy abundance that transcends solar energy limitations. These diverse energy sources create energetic foundations for biological complexity, while providing chemical power systems that could enable advanced biological capabilities including intelligence development and technological innovation through energy abundance that supports complex biological and technological systems. Hydrothermal vent energy production through serpentinization reactions generates hydrogen gas, methane, and complex organic compounds while providing continuous chemical energy sources that could support chemosynthetic biological communities independent of photosynthetic energy production. Hydrothermal energy enables biological productivity while providing chemical foundations that support ecosystem development and biological complexity through chemical energy abundance that transcends photosynthetic limitations. Radiolysis energy generation through cosmic radiation interaction with water molecules produces hydrogen and oxygen gas through water molecule decomposition. Radiolysis providing continuous chemical energy production while creating chemical energy sources that operate independently of geological processes. Radiolysis energy creates chemical production while enabling energy generation through radiation chemical interaction that provides additional energy sources for biological systems. Tidal heating energy conversion through mechanical deformation creates thermal energy that drives geological processes and maintains ocean conditions, while providing thermal energy that could support biological processes adapted to thermal energy utilization. Tidal energy enables geological activity, while providing thermal foundations that support biological activity and biological system development through thermal energy utilization. Chemical energy gradients between different ocean regions create chemical potential differences that could drive biological processes and biological organization through energy gradient utilization. Chemical gradients enabling energy utilization while providing chemical driving forces that support biological complexity and biological system development. Chemical gradients create energy opportunities while enabling biological organization through chemical potential utilization. Biomass energy potential through biological productivity could enable energy storage and energy transfer within biological systems that support complex biological communities and biological interactions. Biomass energy enabling biological energy storage while providing biological foundations that support ecosystem development and biological complexity through biological energy accumulation. Biomass energy creates biological storage while enabling biological system energy through biological productivity. Energy efficiency optimization in aquatic environments could enable biological systems to achieve high energy utilization efficiency through aquatic adaptation and energy conservation strategies. Energy efficiency enabling biological optimization while providing biological advantages that support biological complexity and biological system development through energy utilization optimization. Energy efficiency creates biological advantage while enabling biological optimization through energy conservation. Energy distribution mechanisms throughout ocean volume could enable energy transport and energy sharing that supports biological communities throughout three-dimensional ocean space. Energy distribution enabling biological connectivity while providing energy transport that supports ecosystem integration and biological system development. Energy distribution creates biological connectivity while enabling biological system integration through energy transport mechanisms. Energy storage potential through biological and chemical energy storage systems could enable energy accumulation that supports biological processes during energy scarcity periods. Energy storage enabling biological security while providing energy reliability that supports biological system stability and biological development through energy storage capability. Energy storage creates biological security while enabling biological stability through energy accumulation. Alternative energy utilization through novel biological pathways could enable biological systems to exploit unique energy sources available in subsurface ocean environments. Alternative energy enabling biological innovation while providing biological capabilities that transcend conventional energy limitations through biological energy innovation. Alternative energy creates biological capability while enabling biological innovation through energy pathway development. Energy cascade systems through multi-level energy utilization could enable biological systems to maximize energy extraction through hierarchical energy utilization that supports complex biological organization. Energy cascades enabling energy optimization while providing energy efficiency that supports biological complexity through energy utilization optimization. Energy cascades create energy efficiency while enabling biological optimization through energy hierarchy utilization. Some believe diverse energy sources provide sufficient power for complex biological evolution, including potential technological development based on energy abundance analysis and biological energy requirement assessment, while others suggest that subsurface energy sources may limit biological complexity despite energy diversity that could theoretically support biological advancement. The adequacy of subsurface energy for biological complexity continues to be investigated as bioenergetics research advances and energy-life relationships are understood. Technological energy applications could enable advanced civilizations to utilize multiple energy sources for technological development, including chemical energy, thermal energy, and biological energy for technological innovation. Technological energy enabling technological advancement, while providing energy foundations that support technological civilization development through energy utilization innovation. Technological energy creates technological capability while enabling technological development through energy utilization advancement. Energy sustainability through renewable energy sources ensures long-term energy availability that supports biological system persistence and biological development across extended timescales. Energy sustainability enabling biological continuity while providing energy reliability that supports biological evolution and biological complexity development through energy sustainability. Energy sustainability creates biological reliability while enabling biological development through sustainable energy provision. The irony of abundant subsurface energy lies in its provision of energy resources that could support advanced technological civilizations while remaining completely inaccessible to surface-based energy utilization. Subsurface energy creating technological potential while providing energy abundance that supports biological and technological development in complete isolation from surface energy systems. Energy abundance enabling technological advancement while demonstrating how energy resources can support advanced systems that remain hidden from external detection. Subsurface energy creating civilization potential while providing energy foundations that could support technological development that transcends surface-based energy limitations through energy abundance that supports advanced biological and technological systems. Biomass potential calculations reveal that Enceladus's ocean volume could theoretically support enormous biological populations that far exceed Earth's marine biomass through efficient three-dimensional space utilization and abundant chemical energy sources. Biomass calculations indicating biological abundance, potential that could sustain complex food webs and ecosystem hierarchies, capable of supporting advanced biological communities including potential intelligent species. The vast aquatic habitat combined with multiple energy sources creates biological carrying capacity that could theoretically support biological populations sufficient for complex social organization and technological civilization development. Primary productivity potential through chemosynthetic energy conversion could generate substantial biological productivity that exceeds photosynthetic productivity through chemical energy abundance available from hydrothermal vents and chemical gradients. Chemosynthetic productivity enabling biological abundance while providing energy foundations that support complex biological communities and ecosystem development. Chemical energy abundance creates biological opportunity while enabling ecosystem productivity that could support biological complexity. Food web complexity development through multiple trophic levels could create sophisticated biological interactions that support biological diversity and biological specialization through ecosystem complexity that transcends simple biological systems. Food web development enabling biological complexity while providing biological foundations that support advanced biological communities and biological system development. Food web complexity creates biological sophistication while enabling biological advancement through ecosystem complexity. Ecosystem stratification throughout ocean depth could create biological zonation that supports diverse biological communities adapted to different environmental conditions while maximizing biological space utilization and biological diversity. Ecosystem stratification enabling biological diversity while providing biological organization that supports complex biological systems and biological community development. Ecosystem stratification creates biological organization while enabling biological diversity through biological zonation. Biological specialization potential through environmental diversity could enable biological adaptation that creates biological specialists and biological innovations that support biological complexity and biological system advancement. Biological specialization enabling biological advancement while providing biological capabilities that support complex biological interactions and biological system development. Biological specialization creates biological capability while enabling biological advancement through biological adaptation. Population dynamics modeling suggests that large biological populations could support social organization, cultural development, and potential intelligence evolution through population interactions that enable social complexity and social system development. Population dynamics enabling social development while providing social foundations that support intelligence evolution and cultural advancement. Population size creates social opportunity while enabling social complexity through population interaction. Carrying capacity analysis indicates that ocean resources and energy sources could sustain biological populations sufficient for complex social systems and potential technological development through resource abundance that supports biological community development. Carrying capacity enabling biological sustainability while providing resource foundations that support biological advancement and biological system development. Carrying capacity creates biological sustainability while enabling biological advancement through resource abundance. Resource distribution efficiency through three-dimensional ocean utilization could enable optimal resource access and resource sharing that supports biological communities throughout ocean volume. Resource efficiency enabling biological optimization while providing resource foundations that support biological system development and biological community sustainability. Resource efficiency creates biological optimization while enabling biological sustainability through resource utilization. Biological innovation potential through environmental diversity and energy abundance could enable biological advancement that supports biological complexity and biological system development through biological innovation that transcends conventional biological limitations. Biological innovation enabling biological advancement while providing biological capabilities that support complex biological systems and biological development. Biological innovation creates biological capability while enabling biological advancement through biological development. Ecosystem stability through environmental persistence could enable long-term ecosystem development that supports biological complexity and biological system advancement through ecosystem persistence that provides biological foundations for complex biological evolution. Ecosystem stability enabling biological development while providing biological security that supports biological advancement and biological system development. Ecosystem stability creates biological security while enabling biological development through ecosystem persistence. Community organization potential through biological interactions could enable sophisticated biological organization that supports complex biological systems and biological community development through biological cooperation and biological specialization. Community organization enabling biological complexity while providing biological foundations that support advanced biological systems and biological development. Community organization creates biological complexity while enabling biological advancement through biological cooperation. Some believe biomass potential provides sufficient biological foundations for complex ecosystem development, including potential intelligence evolution based on biomass analysis and ecosystem modeling, while others suggest that biomass potential may not translate to biological complexity despite biomass abundance that could theoretically support biological advancement. The relationship between biomass potential and biological complexity continues to be investigated as ecosystem research advances and population biology understanding develops. Predator-prey relationships could develop complex biological interactions that drive biological evolution and biological adaptation through biological pressure that supports biological advancement and biological system development. Predator-prey dynamics enabling biological evolution while providing biological interactions that support biological complexity and biological advancement. Predator-prey relationships create biological pressure while enabling biological evolution through biological interaction. Symbiotic relationships could create biological cooperation that enables biological advancement and biological system complexity through biological partnership that transcends individual biological capabilities. Symbiotic evolution enabling biological cooperation while providing biological foundations that support complex biological systems and biological advancement. Symbiotic relationships create biological cooperation while enabling biological advancement through biological partnership. The irony of massive biomass potential lies in its creation of biological abundance that could support complex civilizations while remaining completely invisible to external observation. Biomass abundance enabling biological complexity while providing biological foundations that could support advanced biological systems that remain hidden from external detection. Biological potential creating civilization opportunity while demonstrating how biological abundance can support advanced biological systems that operate in complete isolation from external biological observation. Biomass potential enabling biological advancement while showing how biological abundance can create biological complexity that transcends external biological detection through biological development that operates within hidden biological systems. Technology development in aquatic environments would require entirely different technological pathways based on biotechnology, chemistry, and pressure manipulation rather than combustion, metallurgy, and electromagnetic principles that characterize surface-based technological development. Advanced aquatic civilizations would need to master fluid dynamics, biochemical engineering, and pressure-based technologies while developing sophisticated biological tools and chemical processes that enable technological innovation through aquatic adapted technological strategies that transcend terrestrial technological assumptions. Biotechnology advancement in aquatic environments could enable biological engineering through genetic manipulation, biological construction, and living technology systems that utilize biological processes for technological applications. Biotechnology providing technological capabilities while enabling technological development through biological system utilization and biological engineering. Biotechnology creates technological opportunity while enabling technological advancement through biological system integration and biological technology development. Chemical technology development could enable sophisticated chemical processes including chemical synthesis, chemical energy utilization, and chemical manufacturing that support technological advancement through chemical engineering and chemical system development. Chemical technology providing technological capabilities while enabling technological development through chemical process utilization and chemical engineering advancement. Chemical technology creates technological capability while enabling technological advancement through chemical system development. Pressure-based technology utilization could enable hydraulic systems, pressure manipulation, and mechanical engineering that utilizes water pressure and fluid dynamics for technological applications. Pressure technology providing technological capabilities while enabling technological development through pressure system utilization and pressure engineering advancement. Pressure technology creates technological opportunity while enabling technological advancement through pressure system development. Materials science adaptation to aquatic conditions could enable development of water-resistant materials, biological materials, and chemical composites that support technological construction and technological system development. Materials science providing technological foundations while enabling technological development through material innovation and material engineering advancement. Material science creates technological foundation while enabling technological advancement through material development. Energy conversion technology could enable efficient energy utilization through chemical energy conversion, biological energy harvesting, and thermal energy utilization that supports technological development and technological system operation. Energy technology providing technological power while enabling technological development through energy system advancement and energy engineering development. Energy technology creates technological power while enabling technological advancement through energy system development. Communication technology adaptation could enable aquatic communication systems including chemical signaling, acoustic communication, and biological communication that enables information transmission and technological coordination. Communication technology providing technological connectivity while enabling technological development through communication system advancement and information technology development. Communication technology creates technological connectivity while enabling technological advancement through communication system development. Manufacturing technology development could enable production systems including biological manufacturing, chemical synthesis, and pressure-based construction that supports technological production and technological system creation. Manufacturing technology providing technological production while enabling technological development through manufacturing system advancement and production technology development. Manufacturing technology creates technological production while enabling technological advancement through manufacturing system development. Transportation technology adaptation could enable aquatic transportation including biological transportation, chemical propulsion, and fluid dynamics utilization that supports mobility and transportation system development. Transportation technology providing technological mobility while enabling technological development through transportation system advancement and mobility technology development. Transportation technology creates technological mobility while enabling technological advancement through transportation system development. Construction technology development could enable building systems including biological construction, chemical construction, and pressure-based architecture that supports infrastructure development and technological system construction. Construction technology providing technological infrastructure while enabling technological development through construction system advancement and infrastructure technology development. Construction technology creates technological infrastructure while enabling technological advancement through construction system development. Information to technology adaptation could enable data processing including biological computation, chemical information storage, and biological memory systems that support information processing and technological system operation. Information technology providing technological computation while enabling technological development through information system advancement and computational technology development. Information to technology creates technological computation while enabling technological advancement through information system development. Some believe aquatic technology development could achieve sophistication comparable to surface-based technology through alternative technological pathways based on technological innovation analysis and aquatic adaptation assessment, while others suggest that aquatic conditions may limit technological development despite alternative technology potential that could theoretically enable technological advancement. The potential for aquatic technological development continues to be investigated as technology research advances and aquatic adaptation understanding develops. Scientific technology development could enable research systems including biological experimentation, chemical analysis, and observational technology that supports scientific advancement and technological innovation. Scientific technology providing technological research while enabling technological development through scientific system advancement and research technology development. Scientific technology creates technological research while enabling technological advancement through scientific system development. Medical technology adaptation could enable healthcare systems including biological medicine, chemical therapy, and biological healing that supports population health and biological system maintenance. Medical technology providing technological healthcare while enabling technological development through medical system advancement and healthcare technology development. Medical technology creates technological healthcare while enabling technological advancement through medical system development. The irony of aquatic technology development lies in its potential for achieving technological sophistication through completely different technological principles while remaining invisible to surface-based technological detection. Aquatic technology creating technological advancement while operating through technological principles that differ fundamentally from surface-based technological assumptions. Technological development enabling technological civilization while demonstrating how technological innovation can transcend conventional technological limitations through alternative technological pathways that enable technological advancement. Aquatic technological development creating technological capability while showing how technological innovation can achieve technological sophistication through technological adaptation that transcends surface-based technological principles through technological development that enables advanced technological systems. Detection methods for subsurface technological civilizations would require innovative observation strategies including analysis of unusual isotopic ratios, organized structures, and electromagnetic signals that could penetrate ice barriers while providing technological signatures detectable by future space missions and advanced analytical techniques. These detection approaches would need to identify subtle technological modifications to natural systems while distinguishing between geological processes and technological activity through sophisticated analytical methods that could reveal technological signatures despite environmental isolation. Isotopic ratio analysis could reveal technological activity through unusual isotopic compositions that indicate industrial processes, chemical processing, or biological modification that creates isotopic signatures different from natural geological processes. Isotopic analysis providing technological detection while enabling technological signature identification through chemical analysis that reveals technological activity. Isotopic signatures create detection opportunity while enabling technological identification through chemical signature analysis. Organized structure detection through high-resolution imaging could identify geometric patterns, architectural features, or systematic modifications that indicate technological construction and technological organization. Structural analysis providing technological evidence while enabling technological detection through pattern recognition and structural analysis that reveals technological activity. Structural patterns create technological evidence while enabling technological detection through architectural signature identification. Electromagnetic signal detection through radio telescopes and electromagnetic sensors could identify artificial electromagnetic emissions that penetrate ice barriers and indicate technological communication or technological activity. Electromagnetic detection providing technological signatures while enabling technological identification through signal analysis that reveals technological electromagnetic activity. Electromagnetic signals create technological indication while enabling technological detection through signal signature analysis. Chemical signature analysis could identify industrial chemicals, processing byproducts, or technological materials that indicate technological activity and technological development through chemical composition analysis that reveals technological chemical signatures. Chemical analysis providing technological evidence while enabling technological detection through chemical signature identification that reveals technological activity. Chemical signatures create technological evidence while enabling technological detection through chemical analysis. Thermal signature detection could identify artificial heat sources, thermal patterns, or temperature anomalies that indicate technological energy utilization and technological activity through thermal analysis that reveals technological thermal signatures. Thermal detection providing technological evidence while enabling technological identification through thermal signature analysis that reveals technological thermal activity. Thermal signatures create technological indication while enabling technological detection through thermal analysis. Biological modification signatures could indicate genetic engineering, biological construction, or biotechnology applications that reveal technological biological manipulation through biological analysis that identifies technological biological signatures. Biological analysis, providing technological evidence while enabling technological detection through biological signature identification that reveals technological biological activity. Biological signatures create technological evidence while enabling technological detection through biological analysis. Atmospheric modification detection could identify atmospheric chemistry changes, gas composition alterations, or atmospheric processing that indicates technological atmospheric manipulation through atmospheric analysis that reveals technological atmospheric signatures. Atmospheric detection providing technological evidence while enabling technological identification through atmospheric signature analysis that reveals technological atmospheric activity. Atmospheric signatures create technological indication while enabling technological detection through atmospheric analysis. Gravitational anomaly detection could identify mass redistribution, density changes, or gravitational signatures that indicate large-scale technological construction or technological modification through gravitational analysis that reveals technological gravitational signatures. Gravitational detection providing technological evidence while enabling technological identification through gravitational signature analysis that reveals technological gravitational activity. Gravitational signatures create technological evidence while enabling technological detection through gravitational analysis. Seismic signature analysis could identify artificial vibrations, construction activity, or technological processes that create seismic signatures detectable through seismic monitoring that reveals technological seismic activity. Seismic detection providing technological evidence while enabling technological identification through seismic signature analysis that reveals technological seismic signatures. Seismic signatures create technological indication while enabling technological detection through seismic analysis. Acoustic signature detection could identify artificial sounds, technological noise, or acoustic emissions that indicate technological activity through acoustic analysis that reveals technological acoustic signatures. Acoustic detection providing technological evidence while enabling technological identification through acoustic signature analysis that reveals technological acoustic activity. Acoustic signatures create technological evidence while enabling technological detection through acoustic analysis. Some believe detection methods could successfully identify subsurface technological civilizations based on detection technique analysis and technological signature assessment, while others suggest that technological signatures may remain undetectable despite detection method development that could theoretically enable technological detection. The effectiveness of technological detection methods continues to be investigated as detection technology advances and technological signature research develops. Temporal pattern analysis could identify cyclical changes, systematic variations, or temporal signatures that indicate technological scheduling or technological activity patterns through temporal analysis that reveals technological temporal signatures. Temporal detection providing technological evidence while enabling technological identification through temporal pattern analysis that reveals technological temporal activity. Temporal patterns create technological indication while enabling technological detection through temporal analysis. Multispectrum analysis could combine multiple detection methods including electromagnetic, chemical, thermal, and biological signatures to create comprehensive technological detection through integrated analysis that reveals technological activity. Multispectrum detection providing technological evidence while enabling technological identification through comprehensive signature analysis that reveals technological multispectrum signatures. Multispectrum analysis creates technological evidence while enabling technological detection through integrated analysis. The irony of technological detection lies in its requirement for advanced technological capabilities to detect hidden technological civilizations, while demonstrating technological sophistication that could potentially exceed the detected civilization's technological capabilities. Detection technology creating technological requirements while providing technological capabilities that enable technological detection of potentially less advanced technological systems. Technological detection demonstrating technological advancement while revealing how technological detection requires technological sophistication that could exceed detected technological capabilities. Detection technology creating technological paradox while enabling technological detection through technological advancement that supports technological civilization detection. Evolutionary timescales spanning billions of years provide more than sufficient duration for development of complex nervous systems and potentially technological intelligence within Enceladus's stable ocean environment. Evolutionary timescales enabling cognitive evolution through extended biological development that could support intelligence emergence and technological capability development. The 5 billion year ocean stability creates evolutionary opportunities that exceed Earth's biological evolution timescales, while providing temporal foundations for intelligence development that could enable technological civilization emergence through extended evolutionary processes. Nervous system evolution potential through aquatic adaptation could enable sophisticated neural complexity that supports cognitive capabilities including learning, memory, problem solving, and communication through neural development adapted to three-dimensional aquatic environments. Neural evolution enabling cognitive advancement while providing neural foundations that support intelligence development and cognitive complexity. Neural development creates cognitive opportunity while enabling intelligence advancement through neural complexity development. Cognitive evolution pathways through environmental challenges could drive intelligence development through problem-solving requirements, environmental adaptation, and social interaction that promotes cognitive advancement and intelligence enhancement. Cognitive evolution enabling intelligence development while providing cognitive foundations that support technological thinking and innovation capability. Cognitive development creates intelligence opportunity while enabling technological thinking through cognitive advancement. Social evolution potential through population interactions could enable complex social organization that supports cultural development, knowledge transmission, and collective intelligence that enhances individual cognitive capabilities through social cognitive enhancement. Social evolution enabling cultural development while providing social foundations that support intelligence advancement and technological development. Social evolution creates cultural opportunity while enabling intelligence enhancement through social development. Intelligence emergence mechanisms through neural complexity and social interaction could enable consciousness development, self-awareness, and abstract thinking that support technological innovation and technological development through cognitive capabilities that transcend basic biological functions. Intelligence emergence enabling consciousness development while providing cognitive foundations that support technological thinking and innovation capability. Intelligence emergence creates consciousness opportunity while enabling technological thinking through consciousness development. Communication evolution through social interaction could enable sophisticated communication systems, including symbolic communication, abstract representation, and information transmission that supports knowledge sharing and cultural development. Communication evolution enabling information transmission while providing communication foundations that support cultural advancement and technological development. Communication evolution creates information opportunity while enabling cultural development through communication advancement. Tool use evolution potential through environmental manipulation could enable technological development through tool creation, tool utilization, and technological innovation that supports technological capability, development, and technological advancement. Tool evolution enabling technological development while providing technological foundations that support technological innovation and technological capability. Tool evolution creates technological opportunity while enabling technological advancement through tool development. Cultural evolution potential through knowledge transmission could enable cumulative cultural development that supports technological advancement through cultural accumulation, cultural innovation, and cultural transmission that enhances technological capability development. Cultural evolution enabling technological advancement while providing cultural foundations that support technological innovation and technological development. Cultural evolution creates technological opportunity while enabling technological advancement through cultural development. Learning capability development through neural plasticity could enable educational systems, skill development, and knowledge acquisition that supports technological learning and technological capability enhancement through learning systems that enable technological advancement. Learning evolution enabling educational development while providing learning foundations that support technological advancement and technological capability. Learning evolution creates educational opportunity while enabling technological advancement through learning development. Problem-solving evolution through cognitive challenges could enable technological innovation through creative thinking. Analytical capability and innovation potential that supports technological development and technological advancement through cognitive capabilities that enable technological problem-solving. Problem-solving evolution enabling innovation development while providing cognitive foundations that support technological advancement and technological innovation. Problem-solving evolution creates innovation opportunity while enabling technological advancement through innovation development. Memory system evolution through information storage could enable knowledge accumulation, cultural preservation, and information transmission that supports technological development through memory systems that enable technological knowledge preservation and technological advancement. Memory evolution enabling knowledge preservation while providing memory foundations that support technological advancement and technological development. Memory evolution creates knowledge opportunity while enabling technological advancement through knowledge preservation. Some believe evolutionary timescales provide sufficient duration for intelligence and technological development based on evolutionary analysis and cognitive development assessment, while others suggest that aquatic conditions may limit intelligence evolution despite temporal adequacy that could theoretically support cognitive advancement. The relationship between evolutionary time and intelligence development continues to be investigated as cognitive evolution research advances and intelligence development understanding develops. Abstract thinking evolution through cognitive complexity could enable mathematical thinking, scientific reasoning, and technological innovation that supports technological development through abstract cognitive capabilities that enable technological advancement and technological innovation. Abstract thinking evolution, enabling scientific development while providing cognitive foundations that support technological advancement and technological capability. Abstract thinking evolution creates scientific opportunity while enabling technological advancement through abstract thinking development. Technological thinking evolution through cognitive advancement could enable engineering thinking, design capability, and innovation potential that supports technological development through technological cognitive capabilities that enable technological advancement and technological innovation. Technological thinking evolution, enabling engineering development while providing cognitive foundations that support technological advancement and technological capability. Technological thinking evolution creates engineering opportunity while enabling technological advancement through technological thinking development. The irony of intelligence evolution timescales lies in their provision of extensive evolutionary time for cognitive development, while operating in complete isolation from external observation that could detect intelligence development. Evolutionary time enabling intelligence advancement while providing cognitive foundations that could support technological civilization development that remains completely hidden from external detection. Intelligence evolution creating cognitive potential while demonstrating how intelligence development can occur in complete isolation from external intelligence detection through evolutionary processes that support cognitive advancement, including potential technological civilization development. Resource availability within Enceladus's ocean chemistry provides extensive dissolved minerals, organic compounds, and chemical elements that could enable sophisticated material manipulation and construction technologies through chemical resource abundance that supports technological development and material science advancement. The ocean's complex chemistry creates material foundations for technological innovation, while providing chemical resources that could support advanced material engineering and technological construction through chemical abundance that transcends terrestrial material limitations. Dissolved mineral content includes essential metals, rare elements, and chemical compounds necessary for technological development, including iron, sulfur, silicon, and organic carbon that provide material foundations for technological construction and technological system development. Mineral availability, enabling material utilization while providing chemical foundations that support technological advancement and technological capability. Mineral abundance creates material opportunity while enabling technological development through mineral resource utilization. Organic compound abundance provides carbon-based materials, including complex hydrocarbons, amino acids, and organic polymers that could support biological material engineering and biotechnology development through organic resource utilization. Organic availability enabling biotechnology development while providing organic foundations that support biological material manipulation and biological technology advancement. Organic abundance creates biotechnology opportunity while enabling biological technology development through organic resource utilization. Chemical synthesis potential through ocean chemistry enables production of complex materials including chemical composites, biological materials, and hybrid compounds that support technological development through chemical manufacturing and chemical engineering advancement. Chemical synthesis enabling material production while providing chemical capabilities that support technological advancement and technological development. Chemical synthesis creates material opportunity while enabling technological advancement through chemical production. Material processing capabilities through chemical reactions and biological processes could enable sophisticated material modification, including chemical transformation, biological modification, and hybrid processing that supports technological material development. Material processing enabling material advancement while providing processing capabilities that support technological material manipulation and technological development. Material processing creates material capability while enabling technological advancement through material manipulation. Construction material development through resource utilization could enable building materials including biological composites, chemical compounds, and hybrid materials that support infrastructure development and technological construction. Construction materials enabling infrastructure development while providing material foundations that support technological construction and technological system development. Construction materials create infrastructure opportunity while enabling technological development through construction material utilization. Manufacturing resource availability provides chemical feedstocks, biological materials, and energy sources necessary for technological production, including chemical manufacturing, biological production, and technological system creation. Manufacturing resources enabling production capability while providing resource foundations that support technological manufacturing and technological development. Manufacturing resources create production opportunity while enabling technological advancement through manufacturing resource utilization. Material science innovation through resource diversity could enable advanced material development including smart materials, biological materials, and chemical composites that support technological advancement through material innovation and material engineering development. Material innovation enabling technological advancement while providing material capabilities that support technological development and technological capability. Material innovation creates technological opportunity while enabling technological advancement through material development. Resource extraction techniques through chemical processes and biological methods could enable efficient resource utilization including chemical extraction, biological concentration, and hybrid processing that supports resource availability for technological development. Resource extraction enabling resource utilization while providing extraction capabilities that support technological resource access and technological development. Resource extraction creates resource opportunity while enabling technological development through resource access. Chemical engineering applications through resource utilization could enable sophisticated chemical processes including chemical transformation, chemical synthesis, and chemical manufacturing that supports technological development through chemical engineering advancement. Chemical engineering enabling technological advancement while providing chemical capabilities that support technological development and technological capability. Chemical engineering creates technological opportunity while enabling technological advancement through chemical engineering development. Biotechnology resource utilization through biological materials and biological processes could enable biological technology development, including genetic engineering, biological manufacturing, and biological construction that supports technological advancement through biotechnology development. Biotechnology enabling technological advancement while providing biological capabilities that support technological development and technological capability. Biotechnology creates technological opportunity while enabling technological advancement through biotechnology development. Some believe resource availability provides sufficient material foundations for advanced technological development based on resource analysis and material science assessment, while others suggest that aquatic resource limitations may constrain technological development despite resource abundance that could theoretically support technological advancement. The adequacy of aquatic resources for technological development continues to be investigated as material science research advances and resource utilization understanding develops. Recycling technology development through resource conservation could enable sustainable resource utilization, including material recycling, biological recycling, and chemical recycling that supports long-term technological development through resource sustainability. Recycling technology enabling resource sustainability while providing recycling capabilities that support technological sustainability and technological development. Recycling technology creates sustainability opportunity while enabling technological development through resource conservation. Advanced material applications through resource utilization could enable technological innovation including smart materials, responsive materials, and adaptive materials that support technological advancement through advanced material development. Advanced materials enabling technological innovation while providing material capabilities that support technological advancement and technological capability. Advanced materials create innovation opportunity while enabling technological advancement through advanced material development. The irony of abundant aquatic resources lies in their provision of extensive material foundations that could support advanced technological civilizations while remaining completely inaccessible to surface-based resource utilization. Aquatic resources creating technological potential while providing material abundance that supports technological development in complete isolation from surface resource systems. Resource abundance enabling technological advancement while demonstrating how resource availability can support advanced technological systems that remain hidden from external resource access. Aquatic resources creating technological capability while providing material foundations that could support technological civilization development that transcends surface-based resource limitations through resource abundance that supports advanced technological development. Social organization in three-dimensional aquatic environments would develop entirely different territorial concepts, hierarchical structures, and community arrangements based on volumetric rather than surface-based spatial relationships. Aquatic civilizations creating social systems that utilize complete three-dimensional space while establishing territorial boundaries. Resource allocation and social hierarchies that transcend surface-based social organization assumptions. Three-dimensional social organization would enable complex community structures that utilize vertical space, depth stratification, and volumetric territorial control through social systems adapted to aquatic environmental conditions. Territorial organization through three-dimensional space utilization could create volumetric territories that include depth ranges, thermal zones, and chemical gradients rather than surface-based territorial boundaries. Territorial concepts enabling spatial organization while providing territorial foundations that support social organization and community development through three-dimensional territorial control. Three-dimensional territories create spatial opportunity while enabling social organization through volumetric territorial concepts. Hierarchical structures based on depth stratification could create social organization that utilizes depth levels for social status, resource access, and community organization rather than horizontal territorial hierarchies. Depth-based hierarchy enabling social organization while providing social foundations that support community structure and social development through depth-based social stratification. Depth hierarchy creates social organization while enabling community development through depth-based social structure. Community arrangements through fluid dynamics could create social organization that utilizes water currents, thermal circulation, and chemical flows for community connectivity and social interaction rather than fixed surface-based community locations. Fluid community organization enabling social connectivity while providing social foundations that support community integration and social development through fluid-based community structure. Fluid communities create social connectivity while enabling community development through fluid-based social organization. Communication networks through three-dimensional space could create social communication that utilizes acoustic transmission, chemical signaling, and biological communication throughout volumetric space, rather than surface-based communication networks. Three-dimensional communication enabling social connectivity while providing communication foundations that support social organization and community development through volumetric communication networks. Three-dimensional communication creates social connectivity while enabling social organization through volumetric communication. Resource distribution systems through three-dimensional organization could create resource allocation that utilizes depth distribution, thermal resource variation, and chemical resource gradients for community resource sharing rather than surface-based resource distribution. Three-dimensional resource distribution enabling resource allocation while providing resource foundations that support community sustainability and social development through volumetric resource systems. Three-dimensional resource distribution creates resource opportunity while enabling social organization through volumetric resource allocation. Social mobility through three-dimensional movement could create social advancement that utilizes depth migration, thermal zone movement, and chemical gradient navigation for social status change rather than horizontal surface-based social mobility. Three-dimensional social mobility enabling social advancement while providing social foundations that support social development and community evolution through volumetric social movement. Three-dimensional social mobility creates social opportunity while enabling social advancement through volumetric social movement. Cultural development through three-dimensional experience could create cultural traditions that utilize depth exploration, thermal variation, and chemical diversity for cultural expression rather than surface-based cultural development. Three-dimensional culture enabling cultural advancement while providing cultural foundations that support cultural development and cultural evolution through volumetric cultural experience. Three-dimensional culture creates cultural opportunity while enabling cultural development through volumetric cultural experience. Governance structures through three-dimensional organization could create political systems that utilize depth jurisdiction, thermal zone governance, and chemical region administration for political organization rather than surface-based political boundaries. Three-dimensional governance enabling political organization while providing political foundations that support political development and political evolution through volumetric political systems. Three-dimensional governance creates political opportunity while enabling political development through volumetric political organization. Economic systems through three-dimensional resource utilization could create economic organization that utilizes depth resources, thermal energy, and chemical materials for economic activity rather than surface-based economic systems. Three-dimensional economics enabling economic development while providing economic foundations that support economic organization and economic evolution through volumetric economic systems. Three-dimensional economics creates economic opportunity while enabling economic development through volumetric economic organization. Educational systems through three-dimensional learning could create educational organization that utilizes depth exploration, thermal experience, and chemical investigation for learning and knowledge development rather than surface-based educational systems. Three-dimensional education enabling educational development while providing educational foundations that support educational organization and educational evolution through volumetric educational systems. Three-dimensional education creates educational opportunity while enabling educational development through volumetric educational organization. Some believe three-dimensional social organization could enable sophisticated social systems that transcend surface-based social limitations based on social organization analysis and three-dimensional adaptation assessment, while others suggest that aquatic social organization may face limitations despite three-dimensional opportunities that could theoretically enable social advancement. The potential for three-dimensional social organization continues to be investigated as social science research advances and aquatic adaptation understanding develops. Military organization through three-dimensional strategy could create defense systems that utilize depth defense, thermal zone control, and chemical region protection for security organization rather than surface-based military systems. Three-dimensional military enabling security development while providing security foundations that support security organization and security evolution through volumetric security systems. Three-dimensional military creates security opportunity while enabling security development through volumetric security organization. Religious systems through three-dimensional spirituality could create spiritual organization that utilizes depth exploration, thermal experience, and chemical mystery for spiritual development rather than surface-based religious systems. Three-dimensional spirituality enabling spiritual development while providing spiritual foundations that support spiritual organization and spiritual evolution through volumetric spiritual systems. Three-dimensional spirituality creates spiritual opportunity while enabling spiritual development through volumetric spiritual organization. The irony of three-dimensional social organization lies in its potential for creating sophisticated social systems that transcend surface-based social limitations while remaining completely invisible to surface-based social observation. Three-dimensional social organization enabling social advancement while providing social foundations that could support advanced social systems that remain hidden from external social detection. Social organization creating social complexity while demonstrating how social advancement can transcend surface-based social assumptions through social innovation that enables social development. Three-dimensional social organization creating social opportunity while showing how social systems can achieve social sophistication through social adaptation that transcends conventional social limitations. Alternative physics and engineering principles in underwater environments would utilize fluid dynamics, pressure differentials, and chemical processes rather than combustion, metallurgy, and electromagnetic principles that dominate surface-based technology. Aquatic engineering requiring fundamentally different technological approaches that exploit water's unique properties while developing engineering solutions adapted to fluid environments. These alternative engineering principles would enable sophisticated technological systems through water-based physics that transcend air-based technological assumptions while creating engineering capabilities that utilize aquatic environmental advantages. Fluid dynamics engineering could enable sophisticated hydraulic systems, flow control mechanisms, and pressure-based machinery that utilizes water movement and fluid properties for technological applications rather than mechanical systems based on solid materials. Fluid engineering enabling technological advancement while providing engineering foundations that support technological development through fluid-based engineering principles. Fluid dynamics creates engineering opportunity while enabling technological advancement through fluid-based engineering systems. Pressure differential utilization could enable energy generation mechanical systems, and technological applications that exploit water pressure variations and pressure gradients for technological power rather than atmospheric pressure systems. Pressure engineering enabling technological power while providing engineering foundations that support technological advancement through pressure-based engineering systems. Pressure differentials create technological opportunity while enabling technological advancement through pressure-based engineering. Chemical process engineering could enable sophisticated chemical reactions, chemical energy utilization, and chemical manufacturing that supports technological development through chemical engineering rather than combustion-based technological systems. Chemical engineering enabling technological advancement while providing engineering foundations that support technological development through chemical-based engineering systems. Chemical processes create technological opportunity while enabling technological advancement through chemical-based engineering. Bioengineering applications could enable living technology systems, biological machinery, and biotechnology applications that utilize biological processes for technological applications rather than mechanical technology systems. Bioengineering enabling technological advancement while providing engineering foundations that support technological development through biological-based engineering systems. Bioengineering creates technological opportunity while enabling technological advancement through biological-based engineering. Electrochemical engineering could enable electrical systems, electrochemical reactions, and electrical energy utilization that operates through water-based electrical systems rather than air-based electrical systems. Electrochemical engineering enabling electrical technology while providing engineering foundations that support technological advancement through water-based electrical systems. Electrochemical processes create electrical opportunity while enabling technological advancement through water-based electrical engineering. Materials engineering adaptation could enable water-resistant materials, biological materials, and chemical composites that support technological construction through materials adapted to aquatic environments rather than air-based materials. Materials engineering enabling technological construction while providing engineering foundations that support technological advancement through aquatic-adapted materials engineering. Materials engineering creates construction opportunity while enabling technological advancement through aquatic materials engineering. Acoustic engineering applications could enable sound-based technology, acoustic communication, and vibration-based machinery that utilizes water's acoustic properties for technological applications rather than air-based acoustic systems. Acoustic engineering enabling sound technology while providing engineering foundations that support technological advancement through water-based acoustic systems. Acoustic engineering creates sound opportunity while enabling technological advancement through acoustic-based engineering. Thermal engineering utilization could enable heat transfer systems, thermal energy utilization, and temperature control that exploits water's thermal properties for technological applications rather than air-based thermal systems. Thermal engineering enabling thermal technology while providing engineering foundations that support technological advancement through water-based thermal systems. Thermal engineering creates thermal opportunity while enabling technological advancement through thermal-based engineering. Chemical gradient engineering could enable energy systems, chemical processing, and technological applications that utilize chemical concentration differences for technological power rather than chemical combustion systems. Gradient engineering enabling chemical technology while providing engineering foundations that support technological advancement through chemical gradient-based systems. Chemical gradients create chemical opportunity while enabling technological advancement through gradient-based engineering. Biological integration engineering could enable biotechnological systems, living machinery, and biological technological integration that combines biological and technological systems rather than purely mechanical technological systems. Integration engineering enabling biotechnology while providing engineering foundations that support technological advancement through biological technological integration systems. Biological integration creates biotechnological opportunity while enabling technological advancement through biotechnological engineering. Some believe alternative engineering principles could enable sophisticated technological development comparable to surface-based technology through aquatic engineering innovation based on engineering analysis and aquatic adaptation assessment. While others suggest that aquatic engineering limitations may constrain technological development, despite alternative engineering potential that could theoretically enable technological advancement. The potential for alternative aquatic engineering continues to be investigated as engineering research advances and aquatic engineering understanding develops. Membrane engineering applications could enable selective permeability systems, filtration technology, and separation processes that utilize membrane properties for technological applications rather than mechanical separation systems. Membrane engineering enabling separation technology while providing engineering foundations that support technological advancement through membrane-based engineering systems. Membrane engineering creates separation opportunity while enabling technological advancement through membrane-based engineering. Oscillation engineering utilization could enable wave-based technology, oscillation-powered machinery, and vibration-based systems that exploit water's oscillation properties for technological applications rather than rotation-based mechanical systems. Oscillation engineering enabling wave technology while providing engineering foundations that support technological advancement through oscillation-based engineering systems. Oscillation engineering creates wave opportunity while enabling technological advancement through oscillation-based engineering. The irony of alternative aquatic engineering lies in its potential for achieving technological sophistication through completely different engineering principles while remaining invisible to surface-based engineering observation. Aquatic engineering creating technological advancement while operating through engineering principles that differ fundamentally from surface-based engineering assumptions. Engineering development enabling technological civilization while demonstrating how engineering innovation can transcend conventional engineering limitations through alternative engineering pathways that enable technological advancement. Aquatic engineering creating technological capability while showing how engineering innovation can achieve technological sophistication through engineering adaptation that transcends surface-based engineering principles. Evidence assessment from Cassini observations and future missions reveals tantalizing hints of subsurface biological potential while creating frameworks for definitive life detection through advanced analytical techniques and direct sampling missions that could provide conclusive evidence for biological activity beneath Enceladus's ice shell. Current data provides compelling evidence for habitability while future missions including Dragonfly, Europa Clipper, and dedicated Enceladus missions could achieve biological detection capabilities that transcend current observational limitations through technological advancement and analytical sophistication. Cassini spacecraft discoveries through decade-long exploration revealed water vapor plumes, organic compounds, and hydrothermal activity that created foundations for understanding Enceladus's biological potential. Cassini data providing evidence for habitability while establishing scientific frameworks that guide future mission planning and biological investigation strategies. Cassini discoveries created biological investigation opportunity while enabling scientific understanding that supports future biological detection missions. Plume composition analysis through Cassini instrumentation detected organic molecules, dissolved salts, and molecular hydrogen that indicate chemical conditions suitable for biological processes. Compositional analysis providing chemical evidence while revealing chemical foundations that could support biological systems and biological activity. Plume analysis creates chemical opportunity while enabling biological potential assessment through chemical signature analysis. Hydrothermal activity confirmation through silica particle detection demonstrated active seafloor processes that generate chemical energy sources capable of supporting biological communities. Hydrothermal evidence providing energy sources while revealing geological activity that creates biological opportunity through chemical energy generation. Hydrothermal confirmation creates biological potential while enabling biological habitat assessment through geological activity analysis. Future mission capabilities through technological advancement could achieve biological detection through improved analytical instruments, direct sampling techniques, and enhanced sensitivity that enables biological signature detection. Future missions providing biological detection while enabling biological investigation that transcends current analytical limitations through technological advancement. Future missions create detection opportunity while enabling biological investigation through technological advancement. Dragonfly mission prospects for Titan exploration could provide insights into alternative biological systems through surface analysis and atmospheric investigation that reveals biological potential in hydrocarbon environments. Dragonfly exploration enabling alternative biology investigation while providing investigation opportunities that could confirm alternative biological systems through Titan exploration. Dragonfly creates alternative biology opportunity while enabling alternative biological investigation through Titan exploration. Europa Clipper mission applications to ice shell investigation could provide comparative analysis and investigation techniques that inform Enceladus exploration strategies through ice-penetrating technology and subsurface investigation methods. Europa Clipper providing investigation methods while enabling comparative analysis that supports Enceladus biological investigation through ice shell investigation techniques. Europa Clipper creates investigation opportunity while enabling comparative biological investigation through ice shell exploration. Direct sampling mission concepts for Enceladus could achieve biological detection through plume sampling, ice drilling, and direct ocean access that enables biological sample collection and biological analysis. Direct sampling providing biological evidence while enabling biological detection that transcends remote sensing limitations through direct biological investigation. Direct sampling creates biological detection while enabling biological investigation through direct access techniques. Analytical technique advancement through instrumentation development could achieve biological signature detection through enhanced sensitivity, sophisticated analysis, and biological indicator identification that enables biological detection capabilities. Analytical advancement providing detection capability while enabling biological investigation that achieves biological detection through technological analytical advancement. Analytical advancement creates detection opportunity while enabling biological detection through instrumentation development. Biosignature identification strategies through multiple detection methods could achieve biological confirmation through integrated analysis that combines chemical signatures, isotopic ratios, and biological indicators for comprehensive biological detection. Biosignature strategies providing biological evidence while enabling biological confirmation through comprehensive biological signature analysis. Biosignature identification creates biological confirmation while enabling biological detection through comprehensive signature analysis. Sample return mission potential for Enceladus could provide definitive biological evidence through terrestrial laboratory analysis that achieves biological detection capabilities beyond spacecraft instrumentation limitations. Sample return providing biological confirmation while enabling biological investigation that achieves biological detection through terrestrial analytical capabilities. Sample return creates biological confirmation while enabling biological detection through terrestrial analysis. Some believe current evidence provides compelling indications for Enceladus' biological potential based on Cassini data analysis and habitability assessment, while others suggest that current evidence indicates geological processes despite biological potential that could theoretically exist within Enceladus environments. The interpretation of current evidence for biological significance continues to be investigated as analytical techniques advance and mission planning develops. Life detection technology development through advanced instrumentation could achieve biological detection through sophisticated analytical methods that enable biological signature identification and biological confirmation. Detection technology providing biological capability while enabling biological investigation that achieves biological detection through analytical technological advancement. Detection technology creates biological opportunity while enabling biological detection through technological development. Mission planning integration for multiple targets could achieve comprehensive biological investigation through coordinated exploration that combines Enceladus, Europa and Titan investigation for comparative biological analysis, integrated planning providing comparative investigation while enabling biological understanding that supports biological detection through comprehensive exploration strategies. Integrated planning creates investigation opportunity while enabling biological detection through coordinated exploration. The irony of evidence assessment lies in its provision of compelling habitability evidence while requiring extraordinary technological advancement to achieve definitive biological detection. Current evidence creating biological potential while demanding technological capabilities that exceed current analytical limitations for biological confirmation. Evidence assessment enabling biological investigation while demonstrating how biological detection requires technological advancement that transcends current capabilities. Biological evidence creating investigation opportunity while revealing technological challenges that require innovation for biological confirmation through advanced analytical techniques that enable biological detection. SETI and astrobiology implications of subsurface ocean civilizations would require fundamental revision of search strategies and detection methods, since traditional approaches focus on electromagnetic signals from surface-based technological civilizations, while subsurface aquatic civilizations would remain undetectable by conventional radio telescope surveys and optical observation programs. This revelation demands new detection paradigms that could identify hidden aquatic intelligences through alternative signatures including chemical modifications, geological alterations, and indirect technological indicators that transcend electromagnetic communication assumptions. Traditional SETI limitations through electromagnetic focus create detection blindness towards subsurface civilizations that cannot transmit radio signals through kilometers of ice barriers. Electromagnetic SETI requiring surface-based technological civilizations while missing potential aquatic intelligences that operate through alternative communication methods. Traditional approaches create detection limitations while failing to detect civilizations that operate through non-electromagnetic technological systems and communication strategies. Alternative detection strategies for aquatic civilizations could include chemical signature analysis, isotopic ratio monitoring, and geological modification detection that reveals technological activity through environmental alterations rather than electromagnetic emissions. Alternative detection enabling aquatic civilization identification while providing detection methods that transcend electromagnetic limitations through environmental signature analysis. Alternative strategies create detection opportunity while enabling aquatic civilization detection through environmental analysis. Astrobiology expansion through subsurface habitat recognition could revolutionize habitability assessment by including ocean worlds and subsurface environments in biological potential evaluation rather than limiting habitability to surface-based environments. Astrobiology expansion enabling habitat diversity while providing biological potential assessment that includes subsurface environments and aquatic habitability. Astrobiology expansion creates habitat opportunity while enabling biological potential assessment through habitat diversity recognition, Detection method innovation through multidisciplinary approaches could combine astronomical observation, planetary science, and biological analysis for comprehensive civilization detection that transcends single-method detection limitations. Detection innovation enabling comprehensive analysis while providing detection capabilities that support civilization identification through integrated detection methods. Detection innovation creates detection opportunity while enabling civilization detection through comprehensive analysis. Ocean world prioritization in astrobiology research could focus investigation efforts on subsurface ocean environments, including Europa, Enceladus, and other ocean worlds that provide potential habitats for aquatic civilizations. Ocean world prioritization enabling habitat investigation, while providing investigation strategies that support aquatic civilization detection through ocean world exploration. Ocean world prioritization creates investigation opportunity while enabling aquatic civilization detection through ocean world investigation. Technological signature redefinition could expand detection criteria beyond electromagnetic emissions to include chemical processing signatures, environmental modifications, and biological indicators that reveal technological activity through alternative technological signatures. Signature redefinition enabling detection expansion while providing detection criteria that support technological civilization identification through alternative signature analysis. Signature redefinition creates detection opportunity while enabling technological civilization detection through signature expansion. Indirect detection methods through environmental impact analysis could identify civilization effects on planetary systems, including atmospheric modifications, oceanic chemistry changes, and geological alterations that indicate large-scale technological activity. Indirect detection enabling civilization identification while providing detection methods that reveal civilization impact through environmental analysis. Indirect detection creates detection opportunity while enabling civilization identification through environmental impact analysis. Comparative planetology applications to civilization detection could utilize planetary system analysis for identifying anomalous characteristics that indicate technological modification or biological activity through planetary comparison and anomaly identification. Comparative analysis enabling civilization detection while providing detection methods that support civilization identification through planetary anomaly analysis. Comparative planetology creates detection opportunity while enabling civilization detection through planetary analysis. Future space mission integration for CT applications could incorporate civilization detection objectives into planetary exploration missions that investigate subsurface environments and ocean worlds for potential civilization signatures. Mission integration enabling civilization detection while providing detection opportunities that support civilization investigation through space exploration missions. Mission integration creates detection opportunity while enabling civilization detection through space exploration. Biosignature technosignature integration could combine biological detection methods with technological detection approaches for comprehensive analysis that identifies both biological activity and technological civilization indicators. Integrated detection enabling comprehensive analysis while providing detection capabilities that support both biological and technological detection through integrated analysis methods. Integrated detection creates comprehensive opportunity while enabling biological and technological detection through integration. Some believe SETI strategy revision could successfully detect subsurface aquatic civilizations based on alternative detection method development and comprehensive analysis approaches, while others suggest that subsurface civilizations may remain permanently undetectable despite detection method innovation that could theoretically enable aquatic civilization detection. The viability of aquatic civilization detection continues to be investigated as SETI research advances and detection method development progresses. Statistical analysis applications to civilization probability could incorporate subsurface habitat abundance for revised estimates of civilization frequency that includes ocean world habitability and aquatic civilization potential. Statistical analysis enabling probability assessment while providing civilization frequency estimates that include subsurface civilization potential through statistical modeling. Statistical analysis creates probability opportunity while enabling civilization frequency assessment through statistical modeling. International cooperation for aquatic SETI could coordinate global research efforts for subsurface civilization detection through collaborative investigation and resource sharing that enhances detection capabilities. International cooperation enabling detection enhancement while providing collaborative investigation that supports aquatic civilization detection through cooperative research efforts. International cooperation creates collaboration opportunity while enabling aquatic civilization detection through cooperative investigation. The irony of SETI aquatic implications lies in their revelation of potential civilization abundance that remains invisible to conventional detection methods while requiring detection strategy revolution that transcends established SETI approaches. Aquatic civilizations creating detection challenges while providing civilization potential that could resolve Fermi paradox through hidden civilization abundance. SETI implications demonstrating detection limitations while revealing civilization possibilities that transcend electromagnetic detection assumptions through aquatic civilization potential that requires detection, method innovation for civilization identification. The Fermi paradox confronts apparent contradiction between high probability estimates for extraterrestrial intelligence and conspicuous absence of detectable alien civilizations. Subsurface ocean worlds throughout the galaxy potentially harboring numerous advanced civilizations that remain completely invisible to space-based observation and electromagnetic detection methods. Hidden aquatic civilizations could represent abundant galactic intelligence that operates in complete isolation from external detection, while resolving the paradox through civilization abundance that transcends observable technological signatures. Subsurface ocean civilizations, providing potential solution to apparent galactic intelligence absence. Hidden civilization abundance through ocean world prevalence could populate the galaxy with numerous intelligent species that develop within subsurface aquatic environments while remaining undetectable through conventional astronomical observation. Civilization abundance enabling galactic intelligence while providing intelligence prevalence that transcends observable civilization limitations through hidden aquatic development. Hidden abundance creates intelligence opportunity while enabling galactic civilization through concealed aquatic intelligence development. Observational selection bias in SETI research creates detection limitations towards surface-based electromagnetic civilizations, while missing potential aquatic intelligences that operate through alternative technological systems and communication methods. Selection bias enabling detection blindness while limiting civilization detection to electromagnetic capable surface civilizations that represent potential minority of galactic intelligence. Selection bias creates detection limitation while missing civilization diversity through detection method limitations. Galactic ocean world distribution suggests abundant subsurface habitats throughout stellar systems that could support aquatic civilization development through widespread ocean world occurrence and subsurface habitability. Ocean world abundance enabling civilization habitat while providing galactic intelligence opportunity through widespread aquatic civilization potential. Ocean world distribution creates habitat opportunity while enabling galactic civilization through habitat abundance. Technological invisibility through subsurface isolation enables advanced civilizations to develop sophisticated technology while remaining completely undetectable to external observation through technological development that operates independently of observable technological signatures. Technological invisibility enabling civilization development while providing technological advancement that transcends external detection limitations through concealed technological development. Technological invisibility creates advancement opportunity while enabling civilization development through concealed advancement. Communication isolation through environmental barriers prevents subsurface civilizations from establishing interstellar communication or external contact while enabling internal civilization development that operates independently of galactic communication networks. Communication isolation enabling civilization development while providing civilization independence that transcends interstellar communication requirements through environmental communication barriers. Communication isolation creates independence opportunity while enabling civilization development through communication independence. Evolutionary convergence potential suggests that intelligent life could commonly evolve within subsurface ocean environments throughout the galaxy while developing similar aquatic adaptations and technological capabilities through convergent evolution processes. Evolutionary convergence enabling intelligence development while providing intelligence universality through convergent aquatic intelligence evolution. Evolutionary convergence creates intelligence opportunity while enabling galactic intelligence through convergent development. Energy abundance in ocean worlds through geological and chemical energy sources could support numerous advanced civilizations throughout the galaxy, while providing energy foundations that enable technological development and civilization sustainability. Energy abundance enabling civilization development while providing energy foundations that support galactic civilization through energy resource availability. Energy abundance creates civilization opportunity while enabling galactic civilization through energy availability. Temporal persistence through environmental stability enables subsurface civilizations to develop across geological timescales, while maintaining civilization continuity that transcends surface-based environmental limitations and catastrophic events. Temporal persistence enabling civilization sustainability while providing civilization longevity that supports galactic civilization through environmental stability. Temporal persistence creates sustainability opportunity while enabling galactic civilization through environmental persistence. Galactic civilization networks could operate through subsurface ocean worlds that maintain civilization development while remaining isolated from external galactic communication and interstellar contact. Civilization networks enabling galactic intelligence while providing galactic civilization that operates independently of interstellar communication through subsurface network development. Civilization networks create galactic opportunity while enabling galactic civilization through subsurface networking. Alternative technological development through aquatic adaptation could create technological diversity that transcends surface-based technological assumptions while enabling technological advancement that operates through alternative technological principles. Alternative technology enabling technological diversity while providing technological advancement that transcends conventional technological limitations through aquatic technological development. Alternative technology creates diversity opportunity while enabling technological advancement through alternative development. Some believe subsurface ocean civilizations provide compelling Fermi paradox resolution based on hidden civilization potential and galactic ocean world abundance, while others suggest that hidden civilizations may not explain apparent galactic intelligence absence despite subsurface civilization potential that could theoretically populate the galaxy with undetectable intelligence. The viability of hidden civilization solutions continues to be investigated as astrobiology research advances and Fermi paradox understanding develops. Panspermia implications through subsurface environments suggest that life could spread throughout the galaxy while developing within protected, subsurface habitats that enable biological dispersal and biological development across galactic distances. Panspermia enabling galactic biology while providing biological distribution that supports galactic life through subsurface biological development. Panspermia creates biological opportunity while enabling galactic life through biological distribution. Kardashev scale revision for aquatic civilizations could expand technological assessment beyond energy consumption to include aquatic technological capabilities and subsurface technological development that transcends energy-based civilization classification. Kardashev revision enabling civilization assessment while providing civilization classification that includes aquatic civilization through technological assessment expansion. Kardashev revision creates assessment opportunity while enabling civilization classification through assessment expansion. The irony of hidden galactic civilizations lies in their potential resolution of Fermi paradox through civilization abundance that remains completely invisible to galactic observation while demonstrating intelligence prevalence that transcends observable technological signatures. Hidden civilizations creating paradox resolution while providing galactic intelligence that operates in complete isolation from galactic detection. Fermi paradox resolution through hidden abundance while revealing civilization prevalence that transcends detection limitations through concealed civilization development that populates the galaxy with undetectable intelligence. Hidden civilization abundance creating galactic intelligence while remaining invisible to civilization detection through subsurface civilization development that enables galactic intelligence prevalence. The frozen moons of Saturn drift through space like encrypted libraries containing secrets that could rewrite our understanding of consciousness and civilization. Enceladus, harboring beneath its icy shell an ocean that has churned in darkness for billions of years while potentially nurturing minds that have never seen a star. In these hidden aquatic realms, intelligence might bloom in three-dimensional societies that organize around thermal vents and chemical gardens. Their technology is based on pressure and flow rather than fire and metal. Their communications transmitted through acoustic waves that travel through liquid darkness. Perhaps civilizations swim through Enceladus's global ocean at this very moment. Their cities built from living coral that feeds on chemical energy, while their libraries consist of genetic memories passed through generations of aquatic scholars. These potential ocean dwellers would know nothing of seasons or weather, their world consisting entirely of depth and temperature, chemical gradients and hydrothermal mysteries that provide both energy and meaning to societies that measure time in geological epochs rather than solar cycles. The irony deepens when we consider that advanced technological civilizations might exist just 1 billion kilometers away, while remaining completely invisible to our most sophisticated detection methods. Their radio silence not indicating primitive development but rather environmental impossibility. Kilometers of ice serving as perfect electromagnetic shields that isolate entire civilizations from galactic communication networks. Their greatest engineering achievements would involve biological manipulation and chemical processing rather than space travel and electromagnetic transmission. In the thermal layers of subsurface oceans, social hierarchies might organize around access to hydrothermal vents and chemical energy sources. Territorial boundaries flowing like water currents, while governance structures adapt to three-dimensional political spaces that have no analogue in surface-based civilization. These aquatic societies would develop mathematics based on fluid dynamics and navigation systems that track chemical trails rather than celestial objects. Scientific discovery takes on cosmic significance when we realize that SETI's electromagnetic silence might reflect not the absence of galactic intelligence, but rather the abundance of hidden civilizations that develop within environmental cocoons that prevent external detection. The Fermi paradox dissolves into recognition that advanced intelligence might commonly evolve within subsurface ocean sanctuaries throughout the galaxy, each world harboring sophisticated minds that remain forever isolated from interstellar contact through environmental protection. The search for alien intelligence transforms from looking outward to looking inward, into the hidden ocean worlds that orbit throughout our solar system and presumably throughout the galaxy. Every ice-covered moon becomes a potential civilization incubator, where billion-year evolutionary experiments proceed in complete isolation. Biological complexity potentially exceeding Earth's own evolutionary achievements through environmental stability that transcends surface-based catastrophic interruptions. Future space missions carry extraordinary significance as potential first contact opportunities. Robotic explorers designed to penetrate ice barriers and sample subsurface chemistry that could reveal not just microbial life but technological signatures of advanced aquatic civilizations. The next decades could witness humanity's first encounter with alien intelligence through chemical analysis of water plumes rather than radio signal detection from distant stars. As we contemplate these hidden ocean possibilities, consciousness confronts its own cosmic context. Intelligence potentially abundant throughout the galaxy, yet isolated by environmental barriers that create perfect evolutionary laboratories. Perhaps the universe nurtures intelligence through protective isolation, rather than encouraging communication. Consciousness evolving within countless hidden sanctuaries that remain forever separate yet forever significant. The ultimate question transforms from whether we are alone to whether we can develop technologies sophisticated enough to detect hidden intelligence. that operates according to completely different technological principles within environments that shield them from external observation. Saturn's moons become cosmic enigmas that challenge our assumptions about intelligence, technology, and the very nature of civilization itself. In this contemplation of hidden ocean worlds, we discover that the search for alien intelligence might require looking not to the stars, but to the spaces between stars, where ice-covered worlds harbour liquid darkness that could contain minds as sophisticated as our own. Swimming through eternal night while building civilizations that exist in dimensions we are only beginning to imagine, their greatest achievements remaining forever invisible to those who search the cosmos for electromagnetic whispers of distant intelligence.